Alright, I've been studying the Python, messing with C++ for a while. There are certain things that have been discussed that I don't fully understand, so I had to go back. And I was watching a lot of this last night. It's explaining the fundamentals of things that have to do with coding, like the binary system that computers use, the ones and zeros, and how they get turned into code that we use now. And this guy explains things in a very basic form. Someone shows me this in the comments. So I started watching this because the way this guy explains things is very easy to comprehend. Um, so this is where I'm at with it. I believe some of this is going to be interactive. I'm not 100% positive. If you want to tune in, tune in. If not, it's all good. I'm streaming this because it motivates me. Maybe anybody interested wants to see how long it takes to go down this road. Maybe I can learn some things to help other people. I don't know, yeah. But as far as right now, he talked about the introduction of it. If you know what photons are, photons is what we use for, they're particles of light, and we use that to give the ones and zeros. The one would be referred to as like a light being on, and zero would be referred to as kind of like if a light was being off. It's not the exact same as a light bulb and how a photon's working, but it's a close enough example and it works. Now, if you have 4 lights or 3 lights, as he was saying it before, you only have no matter how many lights you have, depending on how many lights you have, if you turn one on and one on here and this off here, you have a combination, and that combination can be linked to a definition, like if one is on here and the rest are off, that could be one, and then one is lit here, and the rest are off, that could be two, or one's lit, one's not lit, one's lit. They can always be something else. He actually described it in a way that how we have this is 123, and the reason it's 123 is because we identify this as a single digit, this is the 10th digit, and this is the 100th digit. So when we see this, we don't just see 1 2 3, but we see 123 because this is associated as a 100th number, and so on and so forth. And with computers, they use the same thing but in a different way. If I can find the picture for it. So basically how this works is this number can only be associated with a 1 and 0. If you have one light and one light turns on and off, it can only be associated with two functions, 1 and a 0. So you have your 1 number here. This is the 2 number. So now that if you have 2, you have a better combination. Now if you have 2 and 1 on, 2 plus 1 equals 3. So you have a total of, you can count up to 3 when you have both of these. And the reason that these numbers are there is because eventually it becomes counted in a sequence where 5, for example, 5 would actually be this one turned on and only this one turned on. 4 plus 1 equals 5. And it uses this sequence of combination because, well, either way you're going to have to use that form of combination. But to keep it in that specific order makes it easier for, well, I guess humans designed this a long time ago, so that made it easier to comprehend and define. Now, of course, it's stretched a long ways there since then. You also have the alphabet to keep in mind, but these are just numbers. Now, where I'm at now is in algorithms, basically spoken algorithms, how algorithms are instructions telling oh man. Hey, what's up? But yeah, I've been watching the crap out of this stuff, trying to learn all these words and stuff. and the part that I'm at is the algorithms. And I mean, I already did the recursion algorithms, but but yeah, that's what he was talking about here, is how with the algorithms you can, instead of just going from like the front of the book to the back of the book, the easiest thing that a human would do is open the book up, see where they're at. Which side do I need to go to? This side. Okay, then you get rid of the other side, and it cuts everything in half, so it gets to the solution faster instead of checking every single thing. 1:15 a.m. Oh yeah, I forgot your time. Okay, I had to take my son. My son had to go to. He had a doctor's appointment that he had to go to, so that's why I got on right now. Yeah, it's I mean, I'm trying to get. As long as I got time to get into this, I try to get into it. But that's what I'm dealing with. So I got a full family with everybody's got stuff going on, and then I finally got to this part. And this part was
the virtual white. So if we have a simple x.
See, this was brought up in the MIT course. He was talking about this, and I did not understand it at all. But it's because he assumed that I guess the people already had that knowledge in mind, and I didn't know what he was talking about. But this guy explained so much simpler, so it all makes sense. But
here,
this is where I'm at.
Axis or vertical is the amount of time to solve in whatever unit of measure, seconds, pages, however you want to count. On the horizontal or x-axis is the size of the problem, measured in, for instance, numbers of pages. So this would mean 0 pages in the phone book. This would mean a lot of pages in the phone book. This would mean no time to solve. This would mean a lot of time to solve. What's the relationship then among those three algorithms? Well, the first one is essentially a straight line, a slope of 1. And if the phone book has n pages in it, we'll describe the slope here as essentially 1/1 for the algorithm with the first algorithm, turning page by page by page. Which is to say, if we were to add one more page to the phone book next year, first algorithm is going to take one more step. But the second algorithm is definitely better. It's definitely faster, but it's still a straight line. So it's going to take roughly n/2 steps on average, because you only have to go through half of the phone book because you're going 2 pages at a time, instead of the whole phone book in the worst case if someone's name is Z.
Him explaining this with the phone book was like so easily to comprehend all this stuff. I wish that other dude had explained it more. He actually explains everything down, so like if you never heard this stuff, so now all this finally makes sense, where it's like, this is, checking every single possibility. Now this is skipping over every single possibility and checking the next possibility.
To go through every page in total. So if we actually compare these, let me just draw some dashed lines. Suppose that you have this many pages in the phone book. If you just draw this vertical white line here, it's going to take this much time in red using the first algorithm, but it's going to literally take half as much time in yellow for the second algorithm, because you're literally going 2 pages at once. But the third and final algorithm is a fundamentally different shape. It instead looks a little something like this. It looks like it's flatter and flatter and flatter. It's always increasing. It never gets perfectly flat, but it grows so much more slowly as a function of phone book size. And for those who recall their logarithms, this would be described as log base 2 of n. And in fact, that's where the math came from. Log base 2 of 1,000 is roughly 10 in total, even if you need a calculator to confirm as much. But this shape is fundamentally different. Why? Well, suppose that Cambridge, where we are, and Alston, the town across the street next year, combine their 2 phone books, and they go from 1,000.
You need more juice?
My juice and my ketchup.
Okay. Oh no! Careful. Well, if this stream shows anything, it at least shows how difficult it is to try to learn something while you have kids.
Pages each to one phone book with 2,000 pages. The first algorithm is going to literally take twice as many steps or pages. Second algorithm is going to take half as many, or 50% more, because you're going 2 at a time. But the third algorithm is going to barely miss a beat. Why? Because if this is 1,000 pages here, and 2,000 pages is over there, just inferring from the shape of the green line, it's not going to be much higher on the vertical axis than the other two were. So more specifically, if you have a 2,000 page phone book next year, how many more steps will it take you using that third and final algorithm?
One more step.
Just one, because you'll divide and conquer a 2,000 page phone book into a 1,000 page phone book, and then you're back at the original story. And that's the sort of power of learning algorithms. That's the power of learning computer science and learning how to program, is to be able to navigate big data, so to speak, things the size of Google, things the size of artificial intelligence training data sets, using better and better, more clever algorithms that perform faster, and therefore not only make the software more competitive, but also make it more usable and more favorable for people like you and me.
Yeah.
Where's the cup?
What?
Where's the cup?
You want to play with Florida? You want to play with Declan? Please help. Okay, well then we're gonna have to turn everything off. You want us to Declan help with her, entertain her, play with her. I'm turning everything off. Go and do it. If y'all keep her from distracting me.
Me when using that software.
Oh my god, I paused it just in time for a commercial. You gotta be kidding me.
So when it comes to implementing algorithms as programmers, as computer scientists, what you're really doing is taking these algorithms, which might be expressed in English conceptually as we just did, but really just translating them to code, be it C or C++ or Python or R or Ruby or any number of other languages that exist in the world. But for now, let's consider how we might implement that algorithm using something that's literally still English, but pseudocode, something that is still correct, but precise and finite, as per Professor Kernighan's advice, which is to say use your own vernacular of English and just say what you mean, but very succinctly. There's no one way to write pseudocode. It's not some formal language. I'm just going to convert the steps I did intuitively to step-by-step instructions as follows. Step 1, what I did was pretty much pick up the phone book. Step 2, what I did was pretty much open to middle of phone book for the third algorithm. Step 3, look at page. Step 4, if person is on page, then step 5, call person. If that does not prove to be the case, step 6, else if the person is earlier in the book, then open to the middle of the left half of the book, and then go back to line 3. Then, else if the person is later in the book, open to the middle of the right half of the book, and again go to line 3.
No, yeah, I appreciate it, GM. I'm trying, dude. I'm trying to lock in, dude. This has been the thing I wanted to do this a long time ago before I got into anything else, but, you know, survivability and the cost of living and all that, so I never got the chance to go to school, so.
3. Else, there's a fourth and final case. If the person, like John Harvard, is not on the page, is not earlier, is not later, what's the fourth scenario we best consider? He's just not there, else we should do something specific like quit. Now, as an aside, everyone in this room has probably had one of these stupid technical support issues where your phone or your laptop or your desktop computer just freeze all of a sudden, or maybe it spontaneously reboots for no reason. Odds are that's because not you, but some other human made a mistake. They probably wrote code working at Microsoft or Apple or Google or somewhere else, and they didn't actually anticipate that, oh, there could be a fourth scenario that could happen in the real world, but if there's no code that tells the computer what to do in that fourth and final scenario, who knows what the computer is going to do? It might by default reboot, it might by default freeze. That's just a hint of the bugs, the mistakes in software to come. But even though this is just one way to write this code, aka pseudocode, there are some salient characteristics that we'll use throughout today. One, there are these verbs, these actions, and henceforth, as aspiring computer scientists or programmers, we're going to start to call these by what more technical audience would. These are functions. A function is an action or a verb. It's like a bite-sized task that a computer can do for you. Those then are functions in this here pseudocode. But there's other types of code in here. There are these things here, if, else if, else if, else. Those are examples of what we're going to start calling conditionals. These are sort of proverbial forks in the road where maybe you go this way, maybe you go this way, but you decide which way to go based on a question. The questions that you ask are what we'll technically call Boolean expressions, named after mathematician Boole. A Boolean expression is a question with a yes or no answer, a true or false answer, a black or white answer, a 1 or 0 answer. There's two possibilities, and there's a hint of the binary underneath. A Boolean expression is going to tell you yes or no, you should go down that fork in the road. Notice what's important here is that indentation mattered as a result. Notice that on line 4, when I first asked if the person is on page, question mark, so to speak, I should only do line 5 per its indentation if the answer is yes or true. I should only open to the middle of the left half of the book and go back to line 3 if person is instead earlier in the book. So indentation in pseudocode and in many programming languages has a logical significance. It tells you whether to do things or not. But there's another construct in here, go back to, which literally makes me go back to line 3, potentially again and again and again, creating some kind of cycle or what we'll typically call a loop instead. So even in this relatively simple real-world algorithm, we have these 4 fundamental characteristics of most computer programs that we will write in this class, and you might write beyond this class, that we have some technical jargon now to describe them. But what's important to note is that line 8 and line 11, even though they're saying go back to line 3, go back to line 3, you might think you're running the risk of what we'll call an infinite loop, where you literally get stuck in a loop forever, which doesn't sound like a good thing if at some point you want to turn your computer off, even though it's still working, but these will not induce infinite loops. Why? What is happening in this particular algorithm every time we go back to line 3 that guarantees eventually we will stop going back to line 3? Exactly. If the person is on the page, we will call them or we will quit. But more importantly, because we keep dividing and conquering the problem, in this case, having the phone book, eventually we're going to run out of phone book, in which case, indeed, John Harvard is either on that page or not, and we will call or we will quit instead. So we'll see in time, and in fact, allow me to promise, odds are at some point you will write code that seems to take control of the computer for you, where it's doing something, and it literally won't respond to you anymore. That's just going to be because of a mistake, a so-called bug that you yourself will invariably have added to your code accidentally, but we'll show you ways for terminating it or breaking out of those conditions. And indeed, what we'll do in just a little bit after a break for today's lecture is explore not just these concepts, but some of the ways you can use them to solve real and very visual and all.
Oh, I gotta get the dogs. Jesus. Well, I think it was actually the neighbor's dog barking, but whatever. God dang, my freaking hair. I'm about to All right, functions are arguments, return values, variables, conditionals are the if and the while and the else. Boolean expressions, when you give it a reason to be caused true or false. And loops are what make you return in an infinite loop.
Audio problem.
Well, I guess not infinite.
But for now, let's at least connect it to something that's been all too germane in recent months, the past few years, namely artificial intelligence, which is a topic we'll come back to at the end of the course too, to give you a sense of like what the connection is with what everyone's been talking about in the world of AI and what it is we're going to spend the next few weeks building up to by writing code. If you were to try to implement something like a chatbot, for instance, that just answers questions and has a conversation with you, you could do that using pseudocode, and as we'll soon see, you can use C, Python, any number of other languages too. That pseudocode might look like this when implementing a chatbot. You could tell the chatbot, if the student says hello to you, then say hello back. And the indentation, as per earlier, implies this is conditional. Else, if the student says goodbye to you, say goodbye to the student. Else, if the student asks you how you are, say you are well. So you can just enumerate question after question after question and just handle all of these conditional possibilities. But things kind of escalate quickly, especially with the tools of today like ChatGPT. Are we really going to have the wherewithal as programmers to write another conditional like else if the student asks why 111 in binary is 7 in decimal? Like this kind of hints at, oh my God, there's like an infinite number of things this human could ask the chatbot. Do we really have to write an infinite number of conditionals? Like that's just not possible. Like there's not enough time in the day, there's not enough lines of code available. Artificial intelligence surely needs to be able to figure some of this out instead.
Are you struggling in your calculus class? Do you have a hard time understanding your instructor? Do you wish there was a simple...
And so indeed, this is not how you implement AI, but rather how you implement an AI like a chatbot is you typically train it based on lots and lots of data. You give it lots of inputs, training data, and let it figure out what it should say in response to certain questions. And it boils down to a lot of probability, a lot of statistics, otherwise known now as large language models, which if we really peek under the hood, are actually typically implemented with what are called neural networks, inspired by the world of biology, whereby we humans have all of these neurons that transmit electrical signals such that my brain tells my hand to move this way, and this other way. And so what computer scientists have been doing over the past many years is implementing in software, using literally zeros and ones, graphs or networks, neural networks that look a little something like this, where each of the circles represents a neuron, each of the arrows represents a pathway between them, and provides as input to these networks huge amounts of data, like all of the internet, all of Wikipedia, all of the books that it might consume as input. And then the goal of this neural network, as per this single final neuron right here, is to produce an answer to a question. Maybe it's simple, like yes, no, or maybe it's something like the answer to the 111 question, or how are you, or goodbye, or hello, or the like. And what these neural networks do is use statistics and probability and try to output the most probabilistically likely answer to this question that's been asked, and really just hope that it is correct. There's no programmer at OpenAI or Google or Microsoft that's trying to anticipate every one of these questions we might ask, not only in English, but in other languages as well. So you might be wondering why there's this like 8-foot duck on the stage. So the persona that CS50's own AI takes is in fact that of a rubber duck, because it turns out in programming circles, and this is true long before CS50, it has often been recommended to students and aspiring programmers that you keep like literally a physical rubber duck on your desk. The idea being, in the absence of a friend, family member, colleague, TA, who could answer technical questions for you, if you're alone in your room and mather at night, you can sort of talk to the duck, maybe door closed, and ask the duck your questions, or more importantly, talk the duck through what confusion you're having. And the mere act of talking through the problem, explaining logically what you're trying to do, what you're actually doing, and what the error actually is, invariably that sort of proverbial light bulb goes off and you realize, oh, I'm an idiot. I hear in my own words where I've gone awry, and even though this duck will never say anything back to you, that alone, rubber duck debugging or rubber ducking, tends to be a valuable programming technique, believe it or not. But thanks to these large language models, we have not only physical but virtual ducks as well. And so available to you will be in this class not tools like ChatGPT and the like, which are through policy disallowed. It is not reasonable to use ChatGPT and the like, but you are allowed and encouraged to use CS50's own AI-based tools, which resemble those same tools but know something about CS50 and aspire to behave akin to a good teaching fellow, guiding you to solutions as opposed to handing you something outright. So this is a tool that will be available at literally this URL throughout the course, CS50.ai. It will also be embedded in the programming environment. You'll see.
I mean, I guess I can't get that, can I? That sounds awesome. What is it? The CS50.ai. Can you get it? Probably not. Duck. This prompt engineering and Copilot.
Soon meet, which is called Visual Studio Code, a cloud-based version thereof. The duck will live in that environment as well as on stage from time to time, which is to say, we'll not only talk about, but use throughout the course, this thing known as AI. But this is ultimately code that we're going to start writing next week, and unfortunately, this code here is written in a language called C. This is essentially the program that I lost 2 points on, like some 25 plus years ago, and it does look admittedly cryptic, and that's why today what we'll focus on, English,
which
physical but virtual ducks as well, and so available to you will be in this class not tools like ChatGPT and the like, which are through policy disallowed. It is not reasonable to use ChatGPT and the like, but you are allowed and encouraged to use CS50's own AI-based tools, which resemble those same tools but know something about CS50 and aspire to behave akin to a good teaching fellow, guiding you to solutions as opposed to handing you something outright. So this is a tool that will be available at literally this URL throughout the course, CS50.ai. It will also be embedded in the programming environment you'll soon meet, which is called Visual Studio Code, a cloud-based version thereof. The duck will live in that environment as well.
Oh, I got Visual Studio. Hold on. Can I download this thing, like, for real? Is it like, I wonder if it's an extension. What is this? What is it called? 50. Oh my god, it's right there. It's the duck. It's the duck debugger, bro. What? Provide everyone with the, oh my god. Oh my god. Okay, it's installed. Dang. How do I use it? Because this is configure tools. No. See, custom agents? No. Tools. Chat settings. How do I make this? How do I use it? Provide everyone with their own virtual. How do you use it. Features. You can run this code with Python. You can download this. You can run it with Python. That's just a Python code. Hmm. It's a command. I don't know. Oh, wait. No, that don't work. Utilize the AI. Okay. I mean, I think this is the AI thing, right? New chat. Chat. How do I use? Okay. In terminal.
No, take a hard. No, oh my, too hard. Okay. Oh, juice.
You need more juice? Dude, you're coming in here every 5 seconds for juice. You're killing me. Goss, Declan.
No.
Goss, Cora.
No. No, Cora might get me. Hi, Olivia. No, not get me mine. Huh? Not get me mine. What did you say? Not get me mine. Oh, you want more juice? No, not get me mine. Okay. gonna give her more. Because
Oh.
I offered, but she didn't want me to. Mama, gonna do.
Oh, it's right here.
On this. I can help you. No. Okay.
Does it do anything? Oh my god. What the heck? Is this it? It just quacks at me? Oh my god. Oh no. You gotta watch where you're walking, Olivia. Goodness. What? What? No. No. Come on. Let's get. Do you want juice? I might as well get some more water while I'm at it. God dang it.
Olivia, come on. Come on, Olivia. Olivia, come on.
Oh no, she's chasing. Why don't y'all play in the room or something? Y'all got both of y'all's rooms y'all could be playing in. Y'all could listen to music or.
Oh yeah, I'll put some music on.
What she loves. You wanna go dance to music? Cora's putting music on. You wanna go to listen to music?
No, mine. This is mine. Wow.
Okay.
I want a TV.
Okay, go watch TV then.
Come here. I'm so tired.
Oh my god. Please.
No. I needed side stuff on the tablet.
I don't care. You need to help me with this. You haven't helped at all. Rosa is trying. You're not doing anything. Entertain her. Play with her. You're not doing anything. You're just sitting there on the tablet. You're not being helpful. Okay, I'm not playing with this duck thing, but that's interesting.
As well as on stage from time to time, which is to say, we'll not only talk about, but use throughout the course, this thing known as AI. But this is ultimately code that we're going to start writing next week, and unfortunately, this code here is written in a language called C. This is essentially the program that I lost 2 points on, like some 25 plus years ago, and it does look admittedly cryptic, and that's why today what we'll focus on is not what this code looks like, nor the zeros and ones that code gets converted to so your computer can understand as input what you want it to do. We're going to focus on a much more visual incarnation of this, but I know thus far this has been a lot, so let's go ahead and take a 5-minute break here, and when we come back in 5, we'll do some actual programming. So see you in 5. All right.
This may be the last ad you ever see. Because with the free AdBlock extension from Capital One Shopping, you can say goodbye to ads on sites like YouTube. That's right, no more interruptions, just nonstop streaming on your favorite sites. And while we're blocking ads, why not save some money too? After you add AdBlock, download the Capital One Shopping extension and get free automatic coupons and rewards at your favorite stores. I have both extensions added to my computer, so I also get free automatic coupons and rewards. Block ads, save money, earn free rewards. What more could you want?
So it's now time to solve with actual code some actual problems, albeit in a fun and visual and audio way, but recall that where we left off was this. Like starting next week, you'll be writing code that ultimately looks like this, but thankfully you will not be writing zeros and ones, and no normal person, myself included, can understand what all of these zeros and ones are at a glance. We could take out some paper pencil and probably figure it out very tediously, but this is exactly the point. Computers only understand this stuff, but what we as programmers will start writing today and beyond is code at a higher level. And indeed, this is going to be frequent within computer science, where there's different levels of abstraction that we operate at. And the lowest level, the nittiest gritty, is like the zeros and ones that computer understand. Like that's it in this class for zeros and ones. Hopefully, you at least have wrapped your mind around why zeros and ones can be used in triples and as bytes to represent higher and higher numbers. But let's just now agree that computers can do that. Let's abstract away from that detail and focus on higher level languages than zeros and ones, namely a language like this. So this is an example of the very first programming language I learned back in the day, as per that homework, in a language called C. It's an older language, but it remains one of the most popular languages and omnipresent languages.
Wait, see, does this still work in C+? Hold on. New text file. If I type that, because it looks like it would still work. I mean, I don't know how different the two languages are. H main void France. If I do it exactly like that, it doesn't run. Wait. Oh yeah, it does. Huh, it works the same as C++. What's the difference?
Nowadays, because it's incredibly fast and it's particularly good at making devices operate quickly. For us pedagogically, the value of C is not that you're probably in Silicon Valley and other such jobs going to be using C yourself that much, but because it's going to provide a conceptual foundation on top of which we introduce other languages like Python, which is newer and improved, so to speak, that gives you more and more functionality sort of for free out of the box by abstracting away some of the stuff we'll focus on in the coming days first. So at the end of the day, you should better understand languages like Python and JavaScript and SQL because of your underlying understanding of a language like C. But this is too much for the first day. Many of you will think that this is too much for the second week. But in fact, C is really only sort of scary looking because all of this darn punctuation and syntax, the semicolon, the parentheses, the double quotes, the curly braces and the like, and I concur, like this is intellectually uninteresting. And a lot of the challenges early on when learning programming is you just don't have the muscle memory like that I or some of the teaching fellows might for knowing what symbols should be where. But that's going to come with time and practice. I guarantee it. What we'll do for today, though, is just throw away all of that intellectually uninteresting detail and focus really on ideas. And some of you might be in your comfort zone here because if back in middle school you were playing with a programming language called Scratch, you were probably using it at the time just to have fun in class or out of class, making games, animations, interactive art. What you probably didn't use it for, at least in middle school, was to consider and explore programming languages themselves. But what's wonderful about Scratch, which is this graphical programming language from down the street at MIT, where it was invented some years ago, is you can program not by using your keyboard per se, but by dragging and dropping puzzle pieces, otherwise known as blocks, that will snap together if it makes logical sense to do so. And what you won't have to deal with is parentheses and double quotes and semicolons and all of that, at least until next week. But the nice thing about Scratch is that after this week and after the so-called problem set 0, the first assignment in which you'll use Scratch, you'll have a mental model via which it will be easier to pick up all of the subsequent syntax as well. So let's see how we can start programming in Scratch by making the simplest of programs first. You can do this at scratch.mit.edu. You needn't do this now in the moment. Problem set 0 will walk you through all of these steps. But what I've done here is opened up at scratch.mit.edu precisely the default web page therein. This is after having clicked the Create button in Scratch, which is going to allow me to create my first program. But first, a tour of the user interface here and what is ultimately available to you. Well, within the Scratch environment, we'll see a few different regions of the screen. One, we have this palette of puzzle pieces at left. The blue ones relate to motion, the purple ones relate to looks, the pink ones relate to sound, and so forth. So the color of the blocks just roughly categorizes what that block's purpose in life is. We're going to be able to use those puzzle pieces by dragging and dropping them from left to right. In the right here, in the middle of the screen, is where I'm going to write my actual programs. This is where I'll drag and drop these puzzle pieces, lock them together, and actually write my code. What am I going to be coding? Well, I'm going to be controlling one or more sprites. Much like in the world of games, if familiar, a sprite is like a character that you might see on the screen. The default character in the world of Scratch is, in fact, a cat that looks like this. And if, in this case, I have just one cat, I can then make that cat do things in his own little world at top right by making the cat move up, down, left, right, spinning around, or doing other things as well. But if you want to introduce a dog or a bird or any number of other custom characters, you just add more sprites and they get their own place in that same world. As for how to think about movement in this world, it's actually pretty familiar, even though it gets a little numeric for a moment. If Scratch at the moment is in the middle of the screen, the cat is at 0, 0. If you think about x, y coordinates or latitude, longitude, if you move the cat all the way up, this would still be x equals 0, but it would be y 180. What's the 180? 180 pixels vertically, or dots on the screen. This is negative 180 pixels on the screen at the bottom. By contrast, if you go left and right, your x value might change, negative 240, but y is 0, or positive 240, and y is 0 as well. But most of the time, you won't need to know or care about what the pixel coordinates of the cat are. All you're generally going to care about as the programmer, most likely, is do you want the cat to go relatively up, down, left, or right, and let MIT figure out the mathematics of moving this thing around in most cases. All right. So let's go ahead and introduce the first of these programs by doing something quite simple, as we did in C there, but a little more simply by writing code as follows. I'm going to go back to scratch.mit.edu. I've already clicked per before, the Create button. And if I click on the yellow category of blocks here at left, and I'll zoom in, we'll see a whole bunch of yellow puzzle pieces. And probably the most common one you will use to write code in Scratch for just this first week is literally when green flag clicked. Why? Well, if we go back over to the cat's world at top right, notice that above the cat's rectangular world, there's not only a green flag for starting, there's a red stop sign for stopping as well. So let's do this. Let me go ahead and click and drag when green flag clicked anywhere into the middle and let go. And now I'm going to go to looks, and it looks like there's a whole bunch of purple puzzle pieces here. I'm going to choose something simple like say hello, drag it, and notice if I get just close enough, it's going to want to magnetically snap together, so I'll just do that, and it does its thing. The fact that there's this white oval with text means that is an input to this say puzzle piece. I can literally then change what the input is if I want to more conventionally say hello, comma, world, which in fact, according to lore, was the very first program written in C, and nowadays in most every language, including in Brian Kernighan's book, so hello world is generally the first program that most any programmer first writes. So that's it, as programs go. Let me go ahead and zoom out here. Let me go over to the right and click the green flag, and somewhat excitingly, maybe underwhelmingly, we've now written a program that quite simply says hello world on the screen. Now let's make this a little more technical for just a moment. What is this here puzzle piece, as I keep calling it? It's actually a similar, it's an incarnation of one of the ideas from our pseudocode before. What did we call those actions and verbs last time in my pseudocode? Functions, that's right. So these purple puzzle pieces here are indeed functions, and some functions, as we can see, take inputs like hello, comma, world. After all, how does Scratch know what to say? You have to provide the cat with input, which is to say functions can indeed take inputs like this. In this case, one input, but we'll see opportunities for passing in more input as well. What the cat is doing, though, visually on the screen here at top right, is what's generally called a side effect. Sometimes when you call a function, it does something visually. And in this case, you're seeing literally a cartoon speech bubble, hello world. That is the side effect of this function. So if we now want to map this to our world of inputs and outputs and see where this side effect is, this is the paradigm I proposed at the start of class that is computer science in a nutshell, and will be the framework we use literally throughout the class, no matter how the languages in particular evolve. So what's the input to this particular program? Well, this white oval, hello world, is my input. The algorithm, step-by-step instructions for solving some problem, is implemented in code, this language called Scratch, by way of this purple puzzle piece. And the output of that function, given this input, is the side effect whereby the cat indeed says hello world visually on the screen in that speech bubble. So the exact same paradigm with which we began today governs how exactly this cat here works. Well, let's actually go back to this program and make it a little more interesting than that. Let me go ahead and click the red stop sign, and let me actually use a different type of puzzle piece, another function that does something a little different. First, I'm going to get rid of the say block, so I'm going to not only pull it away, I'm going to drag it over anywhere it left and just let go, and it will delete itself automatically. Or I could right-click or control-click, and from a little menu, I could also explicitly say delete. And what I'm going to do now is under sensing, which is a light blue shade of puzzle piece. There's a whole bunch here, but I'm going to focus on this one. Ask something and wait. And the default text is what's your name, and that's fine, but because it's a white oval, that input can be manually changed by me if I wanted to change the question. I'm going to drag it over here. It's going to magnetically snap together, and I'm okay with that question, but what do I want to say with the answer? Well, let's go ahead and do this. I could go to looks again. I could grab another say block, let it snap in, and I could say something like, hello, comma, David. But this is going to be the first of many bugs that I make, intentionally or otherwise. Let me click the green flag. Scratch is now, just like in a web browser, prompting me for some input here. So let me go ahead and type in my name, David, enter, and voila, like it works. Hello, David. I'm kind of cheating though, right? Because if I zoom out, stop, and play again, let me type in like Yulia's name here, enter, and it still says hello, comma, David. So that didn't really implement the idea that I wanted. All right, so how can I fix this? Well, it seems that this time I want more than a side effect. I want to use the value that the human types in. And for this, we need another feature of functions, which is that not only can they sometimes have side effects, something visually happens, some functions can hand you back a value. a so-called return value that will allow you to actually reuse whatever the human typed in. So a return value is something that gets virtually handed back to you, and you can store it in something called a variable, like X, Y, and Z in mathematics, and you can generally reuse it one or more times. So let me actually draw our attention then to, at left, not only the blue puzzle piece, ask what's your name and wait, but notice that there's a special puzzle piece below it, this blue oval called answer, and that represents what a computer scientist would call a return value. So MIT has kind of bundled it together side by side to make clear that one of those pieces relates to the other. What it means is that I can do this. I can drag this oval and use this oval as the input to the save function. Now notice it's not the same size, but it is the right shape, so that's okay. Scratch will sort of grow or shrink things to fit properly. But this too isn't quite right. Let me go ahead and do this. Let me go ahead and stop that, click the green flag, I'll type in my name again, DAVID, enter. And it's just kind of like weird or rude, like I wanted a hello at least, and it just said David on the screen. Okay, so I can fix that. Let me stop with the red stop sign. Let me just separate these temporarily, and I can leave it in the middle there, but they have no logical connection temporarily. Let me go back up to looks. Let me grab a say block, a second one, and let me go ahead and say, just to be grammatical, like hello, comma, space, and then I'll reconnect this here. So at the moment, it looks like what I want. I want a hello, comma, and then the return value printed out based on whatever the human typed in. So let me zoom out. Let me click the green flag. Again, what's your name? DAVID, and watch the cat's side effect. Enter. Still not greeting me properly. There's no hello. And if in case it was too fast, let's do it again. Green flag, DAVID, enter. It rudely just says my name, which is weird. What's the bug here, though? It's a little more subtle. Why? Yeah. Yeah, it's just too quickly going over the say command or the say function in this case. My Mac, your PC, your phone is just so darn fast. Both are happening, but too fast for my human eyes to even notice. So we can solve this in a number of ways. I could actually use a different puzzle piece altogether. In fact, MIT kind of anticipated this. Notice the first puzzle piece in purple is say hello for a specific number of seconds. And you can specify not just the message, but the number of seconds, ergo 2 inputs. Otherwise now known as arguments to a function. An input to a function is just an argument now, and that would be a fix here. I could maybe a little more explicitly do this. I could go under events, scroll down a little bit, and under control in orange, I could grab a wait block, and I could kind of insert it in the middle, and this might actually help. So I could click on the green flag, DAVID, enter, hello, David, and I could change the timing to be a little more natural. But what if I want the cat to just say, hello, comma, David, all in one breath, so to speak? Well, for that, I'm going to need to use a slightly different technique as follows. Let me go ahead and get rid of the wait. Let me get rid of the second say block and stop the cat with the stop sign. Let me go under operators here, and let me somewhat cleverly grab this, a join block at the bottom. By default, it's using apple and banana as placeholders, but those are white ovals, so I can change those. Let me drag this over the white oval for the say function and let go, and it will snap to fill. Let me go ahead here and type hello, comma, space instead of apple. And what should I do instead of banana? Yeah, so the answer return value, the return value. So let me go under sensing again. Let me just drag another copy of it, and you can use these again and again and again. They don't disappear. I want to drag answer over banana so that the second input to join is actually, if you will, the output of the ask block, like that, and it snaps to fit. So now, if I go ahead and click the green flag once more, DAVID, enter, now we have the sort of behavior aesthetically that I cared about. But beyond the aesthetics of this, the goal here really was to map it to, again, the same paradigm, which we'll see here. The algorithm and the output and the input for this example are as follows. The input to the say block was, quote unquote, what's your name? The function, of course, implementing that algorithm in code was the ask and wait block. The output, though, of the ask block, recall, is not some visual side effect. It is a return value called answer, like a variable, a special variable like X, Y, and Z in math. But in this one, we generally in programming describe variables with actual words, not just letters. But this output of the say block, I kind of want to make room for it to pass it into the say block as a second argument. So let's do this. Let's take one step back and propose that now for the join block that I just used, it takes two inputs, hello, comma, space, and answer. The function in question is indeed the join block. The output of this had better be hello, comma, David. What do I want to do with the output? So in fact,
I think I'm ready to get on past that.
Interested in sparring with me? A blade unsheathed, its light unleashed.
I thought, in the spirit of sort of thinking back on olden times, thought I'd open up the very first program I wrote when I actually I was cross-registered in an MIT class and took a class that introduced aspiring teachers to Scratch, and I implemented this program here called Oscar Time, which was a game that used a childhood song that I was a fan of, and it allows you to sort of drag trash into a trash can. But to bring this to life, and perhaps in exchange for one stress ball, could get one brave volunteer who wants to come up and control this here keyboard. I saw your hand first. Come on up. Come on up. And you'll see, thanks to the team, we also have this amazing lamppost here, being on Quincy Street as we are. Do you want to introduce loop? Because there's a motion block inside of and what you'll see on the screen are these instructions. Drag as much falling trash as you can to Oscar's trash can before his song ends. And here we go.
Oh, I love trash. Anything dirty or dingy or dusty. Anything ragged or rotten or rusty.
Jesus.
Yes, I love trash.
Oh, there we go. Nice. So as Anna continues to play, let's kind of tease this apart a little bit. So one, there's some costumes on the stage. Like that lamppost is actually never going to move, but there's a couple of sprites. There's the trash can, which seems to be a character unto itself. There's this piece of trash that keeps coming back and back. That is a sprite. There's now this sneaker, which is another sprite. And in fact, notice that Oscar, of course, keeps popping up from his sprite once in a while. So Oscar seems to have multiple costumes. So I offer this as an example as you keep playing, if you would. Very good job so far. Yeah, the song goes on forever. This was a nightmare to implement, to listen to this all day long. But how do we implement the rest of this? Well, notice that the trash, every time she throws into the trash can, does reappear somewhere different. So there's some kind of randomness involved. And indeed, Scratch will let you pick random numbers in a range. So maybe it could be negative 240, maybe it could be positive 240 at the 180 point on the top of the screen. So you can sort of randomly put things on the screen. There's apparently what kind of construct that makes the trash fall again and again. I think no one's listening to me, they're all just watching you. But what's making the trash fall from top to bottom? So it's actually some kind of loop, because there's a motion block inside of a forever loop probably that just keeps moving the trash 1 pixel, 1 pixel, 1 pixel, 1 pixel, 1 pixel, creating the illusion therefore of motion. And if we can crank the song a little bit more, you'll see that this is all synchronized now.
Because they're trash. Oh, I love trash. Anything dirty or dingy or dusty. Anything ragged.
The song keeps going forever, seemingly. And now notice more and more sprites are appearing because they waited for, here we go, climax. All right, a big round of applause for Hannah. Nicely done. Okay, there you go. Here you go. All right, so this is an interminable song, and indeed I spent like hours building that, and just listening to that song on loop was not the best way to program, but the goal here is to really use it as just an intellectual exercise as to how that was implemented. And we won't do the entire thing in detail, because I will say back in the day when I was younger, I didn't necessarily write the cleanest code, and in fact if we see inside this and we poke around the bottom of the screen here, you can see all of my different sprites. And the code is kind of complex. Like, things just kind of escalated quickly, but I did not set out and write all of these programs all at once for each sprite. I pretty much took baby steps, so to speak. And so, for instance, let me open up just a few sample building blocks here that speak to this, that are written in advance. So here's version 0. Computer scientists typically start counting at 0. And let me show you this example here that only has 2 sprites on the screen. We have Oscar the trash can, and we have the piece of trash. And now notice, what does Oscar do? Well, let me go ahead and zoom in on this script, as it's called, the program is a script. When the green flag is clicked, Oscar switches his costume to Oscar 1. That's his default costume where the lid is closed. Then Oscar does this forever. If Oscar is touching the mouse pointer, change the costume to Oscar 2. Otherwise, change it back to Oscar 1. So that whole idea of animation where Oscar's popping in and out is just like a quick costume change based on a loop inside of which is a conditional waiting for the cursor, like Anna did, to get near the trash can. Meanwhile, if we look at the piece of trash here, notice that the trash is actually not doing anything in this first version because I didn't even implement falling first. So let me hit the green flag. Nothing is happening in this very first version, but notice if I click on the trash and drag, as soon as I'm touching Oscar, there comes that trash can lid. And it was just the result of making this one program respond to that input. All right, what did I do next? Well, next, after taking that single baby step, I added one other feature. Let's see inside this version 1. Again, Oscar is behaving the exact same way, but notice this time, the trash is designed to do the following. First, I'm telling the program that the drag mode is draggable. That is, I want the trash to be movable when the user clicks on it. Then I tell the piece of trash to go to a random X location. X is the horizontal, so it's going somewhere between 0 and 240, but all the way at the top of the screen, 180. Then forever, the piece of trash just changes by -1. So it just moves down and down and down. And without looking at the second script yet, let me just hit play and notice, without even doing anything, and eventually once there was lots of trash falling, like Hannah was struggling to keep up with this, it's just moving 1 pixel at a time forever until, thankfully, MIT does stop things automatically if they hit the bottom, lest a 6-year-old get upset that all of a sudden their sprite is gone forever. So there is some special casing there. But what else is this trash doing? Let me zoom in here. The piece of trash, also when the green flag is clicked, is forever asking this question. If you are touching Oscar, then pick a new random location between 0 and 240 at +180 and go back to the top. So in other words, as soon as this piece of trash is dragged over to Oscar like this and I let go, it recreates itself at the top. It's just sort of teleporting to the top, and thus was born this feature. And I won't slog through all of the individual features here, but if we do just one more and see inside this one, so now let me go ahead and hit play. Notice at the top left of the screen there's a score, currently 0, but now when I click the trash and let go, notice that the score is being incremented by 1. And this in fact is how Anna's your score kept going higher and higher and higher. Every time I noticed, oh, the trash is touching Oscar, let's not only teleport, let's also increment a variable. And we didn't see this before, but if I go to this Oscar scratch now, you'll see that it is exactly the same. But if I now go to the trash piece here, and we go to when green flag clicked, you'll see that I'm initializing a variable in orange called score to 0. But if we scroll down to the bottom, Oscar is also doing another thing in parallel at the same time. And change X.
What if I told you this dish was actually healthy? Let's be real, Factor's menu is way healthier than the competition. Their chefs actually
by 1, so bounce in the other direction. Else if you're touching the right, only touching that there black line, it's still gonna stop as well. So intuitively, how could you implement that type of program? How could you get a... Well, let me introduce one final set of examples here, this one written by one of your own predecessors, a former student. Let me go ahead and open up 3 baby steps, if you will, toward an end of implementing a game called Ivy's Hardest Game, whereby it's now more interactive, quite like Oscar time. So at top right here, notice, and I'll zoom in, we have this world that's initially very simple. 2 black lines, 2 walls, if you will, and a Harvard sprite in the middle. But when you click the green flag, notice that nothing happens initially except that the sprite jumps to the middle, but I can hit the up key, or the down key, or the left key, or the right key. But if I try to go too far, even though it's not the edge of the world, it's only touching that there black line, it's still gonna stop as well. So intuitively, how could you implement that type of program? How could you get a sprite, from what we've seen, to respond to up, down, left, right, but actually move when I touch my arrow keys? Like, what does it mean to move? Yeah. Exactly. So much like with representing information, at the end of the day, all we've got is zeros and ones. When it comes to algorithms, at the moment, all we have are functions and loops and conditionals and Boolean expressions and soon some more things too, but there's not all that much we have at our disposal. So let me zoom out from this and let me actually show you what the Harvard sprite is doing. It's doing this. When I go up to the green flag here, the Harvard sprite is going to 0, 0, so dead center in the middle, and then it's forever doing two things, listening for the keyboard and feeling for walls, left and right. Now those are not puzzle pieces that come with Scratch. I created my own custom blocks, my own functions, to implement those ideas. Let's not abstract away for now. Let's actually look at these features, and indeed, to your instincts at left here, what does it mean to listen for the keyboard? Well, if the up arrow key is pressed, change Y by 1, move up. If the down arrow key is pressed, change Y by -1. If the right arrow key is pressed, change X by 1. If the left arrow key is pressed, change X by -1. So take sort of and just touch it, at which point you move to the next level. At the next level, of course,
Yale,
has Yale doing
Harvard,
its
and
thing
Yale.
back and forth.
Oh my god.
But you've made it to level 3. But now there's 2 Yale, so another sprite is in the mix that's randomly moving a little different in terms of direction. 3 Yales. Next level, MIT's
MIT,
in.
oh my god.
Nice.
Oh my
The
god.
walls are now gone. Princeton's in the mix.
Oh man. God.
Nice. 2 Princetons.
Ugh. The dude's like, hold up.
Okay, new life. Okay, another life. Nice, nice. Oh. Nice. Second to last level. 3 Princetons. Last level.
God damn. Jesus. That was ridiculous.
Here. All right. This thing.
Okay, let me get on with this. Oh, this identified this as C. Oh, that's interesting. I didn't even notice it. This is CS50. This is week 1 because, of course, last week was week 0, and this is the week where we'll actually start programming in a much more traditional way, that programming language we promised called C. Of course, we started with this, and hopefully by now, with problem set 1, you've had a little bit of fun, even if you've played with it before, and the goals of Scratch, beyond sort of making things feel very accessible and user-friendly, is really to elucidate some of the fundamental concepts that we'll see again today, and really every week subsequently, like functions and conditionals and loops and variables and so much more. And in fact, among the goals of Scratch is, again, to kind of plant these visuals in your mind, so even as today onward feels all the more like a fire hose, especially when it comes to really weird, cryptic, textual syntax, the ideas are still going to be the same. So today, this program, Hello World, becomes this instead. And in fact, just to color code things temporarily, I dare say that what I've color-coded here in orange, which looks probably, to those of you who've never programmed, pretty cryptic,
is the equivalent of the when green flag clicked orange puzzle piece like this. What remains is just one line in purple with a bit of white, which is what ultimately is going to get the screen today to say hello world on the screen. And of course, we had a name for something in purple. In fact, if we rewind to week 0, this block in purple represented what type of functionality? A function itself, an action, a verb that gets the computer to do something. So what looked like this last week is about to look like this. Let's take away the color coding and focus really on what we're going to now start calling source code. So this is what programmers do in the real world. This is what software developers, software engineers do in the real world. They write code that looks like this. And clearly it's a little English-like, but it's not English in the way you would compose an essay or an email. Clearly there's some patterns and some special syntax to it that we'll highlight ultimately today. The problem is, though, that computers, of course, don't understand source code. They only, per last week, understand like zeros and ones. That is it, the so-called binary system. So somehow we've got to get what already looks cryptic into something that looks at a glance even more cryptic, the zeros and ones that computers do understand. And for today's purposes, just know that built into your Macs, PCs, and phones, there is a built-in understanding of what these patterns mean. Maybe it means a number, maybe it means a letter, but today maybe it means an instruction, like print something on the screen, or save something, or load something. That is to say, computers use patterns of bits not only to represent all the stuff we talked about last week, numbers, letters, colors, images, sounds, and all of that, they also use patterns of bits to represent.
Started watching this Harvard stuff to get down to basics and whatnot. I was skimming through it for a little bit, but I mean, I like the way he was explaining a lot of stuff. It makes a lot of stuff make more sense.
Fundamental functionality, print things, play things, much like those same scratch blocks. But no computer scientist really, unless they take out a paper pencil or write a program or use a website to convert this, can sort of read this and know what's going on. That's why we humans are actually going to use not machine code, as it is called, the zeros and ones that computers understand. We are going to start writing source code. And last week you already wrote source code, but in the form of dragging and dropping those puzzle pieces. So this too is going to be the paradigm that sort of guides us through the entire semester. Problem solving, programming is really about input becoming output, and we'll focus today then on a certain type of input becoming output. Someone has to get the source code that's written in a language like C into the machine code, the zeros and ones that the computer actually understands. So source code today is going to be our input, machine code is going to be our output, and we're going to give you today a special program called a compiler whose purpose in life is to translate one to the other. And there's compilers for different languages in the world. We're going to focus on one that supports today's language, known as C. And here, as promised, is the programming environment we're going to use. It's tailored to CS50, which is to say we've pre-installed certain software that you might find useful during the term. But for all intents and purposes, the tool you will use for CS50's problem sets henceforth is a very popular industry standard tool called Visual Studio Code, or VS Code for short. We are using a cloud-based version of it that lives at literally this URL, cs50.dev. You can sign into that so long as you have a free GitHub account with which you, for which you signed up presumably already. And that will give you access to not only an industry standard programming environment, but again, an environment that has some CS50 specific things pre-installed. And at the end of the semester, or even in the middle if you're so inclined, you can actually download for free VS Code onto your Mac PC. You can disconnect from the internet and you can actually program on your own computer. Caveat though is that you tend to hit technical support headaches in the very beginning of the term, so we suggest you do that later in the term once you're already comfortable with this cloud-based environment here. And here it is. This is what programming shall look like, whether we're using C now, or Python in a few weeks, or JavaScript, or SQL thereafter. So here is what is VS Code configured as follows. At the top right, you'll generally have one or more tabs for code, much like tabs in a browser. And this is where you'll write code that looks a little something like this. And in fact, this is exactly the code that you saw a moment ago. What VS Code does, among other things, is it actually highlights your code for you. It colorizes it in what's generally an illuminating way. So I did not choose to make this red, I did not choose to make this blue and this purple. The computer sort of automatically does that for you, as we'll soon see, to sort of draw your attention to different ideas in the program itself. That all happens automatically. At the bottom here, you're going to use a more advanced interface today onward, known as a command line interface in the form of a terminal window. So you can still use your mouse or trackpad and click and drag and do things like that in this environment, but you'll find, and many programmers prefer, that it's much more efficient ultimately to use your keyboard more often than the mouse or the trackpad. So we'll introduce you to that text-based terminal window there. Up here at top left, you'll have a file explorer. So what's nice about VS Code is that not only will you have textual commands with which you'll get comfy, you also have, like a normal Mac or PC or phone nowadays, like literally files and folders will visually appear to you, so you can play with or manipulate them there. And then lastly, this is sort of like the menu, the so-called activity bar that just has icons for various features, including CS50's duck. So in fact, if you poke around, you'll see ultimately a duck icon when you log in, which is your own CS50 specific chatbot of which you can ask questions throughout the process. So now that we've got VS Code here, let's go ahead and actually consider what it represents. So this is generally, for jargon's sake, a graphical user interface, which means buttons and icons and menus and all of that. We all take that for granted on most any device nowadays. That's abbreviated, just so you know, as GUI, G-U-I. But built into VS Code, again, is what's not only the terminal window by name, but conceptually, this is a command line interface. So not a graphical user interface, but a command line interface, whereby there aren't icons to click on or double click on. Rather, if you want to run a program, you use the command line interface, or CLI, to type the name of the program that you want to run. And so this will feel like a step backwards initially today, because we all sort of tap and point and double click at things nowadays. But again, it's going to give us more power, more efficiency, ultimately beyond this. So with that said, let's go ahead and actually use it for just a moment. During class, you're welcome to follow along, but suffice it to say, we'll generally go somewhat quickly. Really, you're going to learn how to program by way of the problem sets each week. I'll introduce and focus on the concepts, the ideas, the sort of primitives that will get you started, but only through actually doing the problem sets is the muscle memory and practice going to come. So not to worry if it doesn't all sort of go down easily the first time around. So here is the code that I claim is equivalent to last week's Hello World program. Let's actually go ahead and do this in the programming environment. So I'm going to go ahead and switch over to VS Code itself, which is now running on my Mac here. It's not just a screenshot. And I'm going to go ahead and do the following to get started with programming. I'm going to write literally in my terminal window the word code. And I might have to give it focus by clicking down in that quadrant of the screen. And then I'm going to give the name of the file that I want to code. And in this case, I'm going to propose that we call it hello.c. In the world of Scratch, when you downloaded it, you might have noticed the files are all called like SB3 or some such file extension. When writing code in C, you literally name the file something .c by convention. But notice some other details, especially if I zoom in. Everything I've typed thus far is lowercase. There's no spaces, and so this is going to be important. And unfortunately, computers are not forgiving. And odds are one of the first stupid mistakes you'll do is miscapitalize something, misspell something, add too many spaces or the like. Not to worry. Like in time, that kind of muscle memory will come with practice. So let me zoom out. Let me now just hit enter, and you'll see at top right the code tab that I promised. So I'm going to go ahead and type out this program pretty quickly, because I've done it before. Include standard io.h, int main void, and then some curly braces as they're called, and then printf, quote unquote, hello, comma, world, \n, close quote, semicolon. All right, so that's a lot, but that too will come in time with practice. But this is the exact same code that we saw just a moment ago. Indeed, if I zoom in, it's color-coded just as in the screenshot, and thus I have written my first program. VS Code will automatically save for you, but you can also hit Control or Command S to ensure that it's saved. But notice what's happened at top left. Not only do you see my code over here, you see a visual icon, just like on a Mac or PC, that yes, this file now exists in your account. And that too is what you're getting with VS Code for CS50. You're getting your own sort of server in the cloud. It's called a container nowadays. So there's some virtual disk space somewhere in the cloud, a la iCloud or Google Drive, that's going to store all of your files. And at the moment, because I refreshed my account before class, I only have one file in my own account. What's this? What's this? Well, this is like my ID number for GitHub. Not really a big deal. That's just randomly generated by GitHub. Urban Adventure is the name of my programming environment today, otherwise known as a code space. This is just a GitHub thing, which is, again, one of these cloud companies. Instead of choosing like random letters and numbers to uniquely identify all of our programming environments, it's popular in the tech industry nowadays to just put together random folder. Sort of the dot implies this current folder, and / just means something in this current folder. Run the program called hello. So that's it. Like there's 3 steps to run this program. The ID number for GitHub, GitHub, not really a big deal. That's otherwise known as a code space. This is just a GitHub thing, which is, again, one of these cloud companies. Instead of choosing like random letters and numbers to uniquely identify all of our programming environments, it's popular in the tech industry nowadays to just put together random English words that sometimes sound kind of cool. But it's just by coincidence.
Yeah, the thing that he did in the terminal doesn't work in what I'm working with. I'm using Visual Studio, but I mean, I think that's what I don't know. But yeah,
It's not something I chose. Yours will be different. All right, so like I've written some code. I created hello.c. I typed in all of that code. I confirmed visually at left that it was created. I'm going to hide my file explorer henceforth just so we can focus on the code. How do I actually run this program? Well, on a Mac or PC, we would be in the habit of like opening the folder and double-clicking on it. Or on your phone, you would take it out and tap on an icon. But not here. Here, we're focusing primarily on the command line interface within this whole environment. So I'm actually going to have to introduce a few commands. You saw already the code command, which for our purposes is VS Code specific. That just creates a new file called hello.c in this case. But I need two other commands to actually run this program. The first, nicely, is called make, and then I specify what program I want to make. And then a little weirdly, I have to type /hello. But just to take a step back, make hello. If this is about to be my second command that I type, what does that step represent, perhaps? Given what I said just a minute or so ago. Perfect. So make represents the compiler, so to speak, the program that converts source code to machine code. I have to do that for now manually by running make hello. Now make is kind of smart, and even though I'm saying make hello, not make hello.c, make is smart, and it's going to say, oh, if you want to make a program called hello, I'm going to assume that there is somewhere in this folder a file called hello.c, so you should not type make hello.c, you just type make hello. And then this third command, even more cryptic, what might it do? This is step 3 of 3. That's going to run the machine code. It's going to tell the computer in this folder, sort of the dot implies this current folder, and / just means something in this current folder, run the program called hello. So that's it. Like there's 3 steps to writing a program in C. You create the file, as with the code command, but there are other ways to do that too. And you don't even have to use VS Code. You can use dozens of other alternative programs in the world. You run the compiler, which in this case is called make. Little white lie, make's not actually the compiler, but more on that next week. But make is going to trigger compilation of this code. And the last step 3 is to execute or run the program called hello. So let me go back to VS Code here. And you'll see that my code is still at the top. My terminal window's at the bottom. I hid my file explorer just because it's not that interesting anymore. And I'm going to do what you proposed, which was make space hello, all lowercase, enter. And ironically, thankfully, nothing happened. And that's actually a good thing in this environment. If nothing seems to happen, like you probably did good. If anything does seem to happen on the screen, you probably screwed up and you've made some mistake. So seeing nothing is generally a good thing. But what has happened? Well, let me actually go back and open up my file explorer and notice there's not only hello.c, but there's a second file now, hello, which is the name of the program. So hello is the program I want to run. I'm going to go back to my terminal here, and to run this program, I'm going to do /hello. I'm going to cross my fingers, as I'll often now do, and voila, my very first program in C. How else can we see this file? Well, down here in my terminal window, let me zoom in. You keep seeing a $sign. That has nothing to do with currency. It's just a weird, geeky convention that your prompt at a terminal window, like where you type commands, generally starts with a $sign. Sometimes it's a hash symbol. Sometimes it's an angled bracket. Depends on the system you're on, but $sign is very common. It just means type your commands here. Well, I've typed code, I've typed make, and I've typed /hello, but I can type other things too, and more on these later, like ls. Which doesn't actually spell something, but is short for list, L-I-S-T. Programmers tend to just be as succinct as they can, so most commands are not full words. They're often abbreviations. If I hit enter now, you'll see also 2 things. You'll see hello.c, and you'll see in green, just to draw attention to it, hello as well. The asterisk here just means, in the programming environment, this program is executable. Like you can actually run this by doing /hello. The fact that this is just white here, that just means it's some text file. It's in fact source code. So in other words, ls lists the file in my current folder, or you can use your human eyes in the File Explorer at top left and just look at what files exist. These are one and the same. One is a GUI, one is a CLI, graphical, command line, and so forth. And we'll start to take these kinds of paradigms soon for granted. But let me pause here and see thus far, now that we've written our first of many C programs, any questions or confusion we can clear up. It's okay if you don't understand most of the lines of code. That's what today is about. Yeah? What's the difference between hello and hello.c? So hello.c is literally my source code. It is a file that exists somewhere in the cloud that contains all of the code I myself wrote. The hello file is the file that the compiler created for me by converting the source code to the machine code. So inside of hello, theoretically, is a whole bunch of zeros and ones. We can't quite see them, but if I do this, let me zoom out. Let me click on hello, and notice that VS Code is going to yell at me. This file, the file is not displayed in the text editor because it is either binary, that is zeros and ones, or uses an unsupported text encoding, whatever that means. If I do open it anyway, but I don't recommend this, like heed these warnings, you won't see zeros and ones, but you will see sort of nonsense. And this is because VS Code is trying to interpret those zeros and ones incorrectly.
What are they doing? Why don't they just explain how to set up a normal compiler? But I don't know. They're definitely using something different than Visual Studio, so I'm not sure. I'm just going with it, trying to see when it's going to get to some. They're using a terminal, but I don't know if they're using like the standard. I don't know. Because he said that whenever they create a file, it's synced to their cloud for that class or whatever. So I don't know what program. I guess is a program they have linked into their own school, but yeah.
As ASCII text, like English text, but it's not. They're instructions for the computer. So as soon as you see scary red stuff like this, like undo, close whatever tab you open, because odds are you can only break the program you just created. It's not a huge deal. You can recreate it, but that's what's inside of those files. Yeah? Really good question. What if we don't type /hello, we just type hello? Well, let me do this. Let me hide my File Explorer again, because it's not that interesting here on out. I'm going to clear my terminal window by hitting Control-L just to be neat and tidy in class, where you can literally type clear and it will clear it. But again, that's just to keep things tidy. Your TFs might do that in section 2. If I just type hello, enter, I'm going to get this, weirdly, bash hello command not found. So more on bash down the line, but this just means literally the command hello is not found because you need to tell the computer where it is. So /hello means run the hello program that is, in fact, right here. By contrast, you don't run / for code, for make, or other commands that we'll soon see like ls, because why? Those are installed in the system for everyone, not just in your individual folder. So that's the difference. Any programs we write, it'll be / something. All right. So let's tease apart what is actually going on here and see if we can lean heavily today on Scratch, especially as the syntax gets weird, perhaps a little overwhelming, still the same idea. So this last time, of course, was our Scratch program that just said hello world. I claim today that this is the nearest equivalent that any programmer could convert Scratch into C. If we color code it accordingly, indeed, this sort of lines up with when green flag clicked is the orange, and then the purple is just the equivalent of the say block. So the say block.
That's what it seems like, because you can't do that in the terminal. Like, if I want to type something in the terminal, I got to put, like, echo and then put, like, hello world. I don't know why they're... I don't know. And then I forgot how to do... Yeah, let's type 2 words. I forgot how to do it on 1 word, but... Yeah.
Like we said earlier, was a function. So let's compare these things side by side, because there's actually some rhyme and reason to what MIT did with Scratch as to why these shapes look like they do, and so forth. So in Scratch, there's a function called say. Recall that it takes an input, otherwise known as an argument, or a parameter is another name, and that's always provided in these white ovals, 1 or 0 or more white ovals. In C, we've already seen, but let's do it a little more pedantically, the equivalent of say is essentially the word print. Why did MIT say use say? Just because it's a little more kid-friendly, but print is the idea in our environment. It's actually not print, it's printf, because we're going to be able to format our text in interesting ways. More on that in a moment. But notice the opening parentheses and closing parentheses here sort of conjure up the idea of that white oval. So that's kind of intentional on MIT's part. What, though, in C goes between these parentheses? Well, literally the input or the argument you want to pass to the function, like hello world. But in C, you have to be a little more pedantic because you don't have a nice little graphic. All right. So let's tease apart some other features of this in every program we're going to write, namely what's at the top of this file. So at the very top of this file, there is this cryptic-looking hash include, or pound include standard io.h in angle bracket. So this is a little weird. We'll talk more about this next week too, but this is what's called a header file. Any file that ends in .h is not a source, well, any file that ends in .h is what we're going to call a header file. And inside of that header file is functionality that maybe came with the system, came with the programming language itself. So for instance, I'm going to do this. I'm going to go back to my code here, and I'm going to make a very common mistake that you yourselves might make in the coming days, where I just forget that line, because I don't even understand it in the first place, so I certainly didn't think to type it here. Now, if I go back to my terminal window after clearing it, and I run make hello, because I want to recompile it, because I've changed the source code, I'm going to see a fairly cryptic error. I mean, there's more error on the screen than there is code.
I have C++. I don't know what clanged is. I don't know. I'm not sure exactly what you're asking. I mean, I got Visual Studio, I got C++ working, and I mean, I got the normal C working, but I don't know what clanged is or GCC.
Up here, but you'll get the hang of sort of reading it to try to figure out what's going on. And I'm seeing this, hello.c, line 3, character 5. So that just means line 3 colon character 5 from left to right. It's sort of a visual cue as to where the problem is. Call to undeclared library function printf with type ... And then the rest kind of overwhelms me.
Yeah, I guess I did because, I mean, I'm able to run it. We were messing with that. Me and GM were messing with that like a lot the other day to try to get C++ to work, and it took me forever to mess with it. I was having a lot of issues with it, but yeah, I don't know which if there was specific ones I downloaded, but I mean I got it working, so.
Visually at this point, but that's a hint. If you do not include that header file at the top of the code you've written, you do not have access to what's generally called a library. A library is a collection of code that someone else wrote for you. Maybe it was MIT, maybe it was the authors of the C language itself years ago, maybe it was CS50 if we wrote some code for you. A library is a collection of code that someone else wrote for you, and you access it again by including header files that those same people wrote for you. So if I go back to my code now, let me clear my terminal window just to be less overwhelmed. Let me undo what I just did and put that file back. Can you perhaps infer, just functionally, what is inside of standard io.h that, again, someone else wrote? What must be inside? Printf. So whoever invented printf decades ago probably put that code in this file, and so by including it, so to speak, in my code, I now have access to printf functionality. So that's all. And again, C is lower level than Scratch. It's obviously text-based, which means you have to be a little more pedantic yourself as to what you want the computer to do for you, and if you want to use someone else's code, you indeed have to include it. Scratch didn't bother with this, but we indeed do need to do this in the context of C. As an aside, just to preempt some unnecessary headaches, this word is not studio.h. Every year, a non-zero number of people can't understand why their code's not working because studio.h is not found. It's standard IO, stdio.h. That's one of the first frequently made mistakes otherwise. All right, so remember that. Let me undo now the unnecessary quotes I added here, and let me propose that we show you where you can learn more. So all of these libraries generally are documented, like people wrote instructions for how to use them. So you don't just have to listen and pay attention only in class. You don't have to pull up a book. There tends to be online documentation as well. For instance, for the standard IO header file. And the documentation in the world of programming for C, specifically, are called manual pages, or man pages for short. Unfortunately, they're really written decades ago for like the more comfortable among you, those who have an eye already for programming. And so what CS50 has done at this URL, manual.cs50.io, is we essentially have more user-friendly versions of the documentation for this header file and others. So for instance, if I pull up manual.cs50.io, you'll see a web page like this. And if I just scroll quickly, you'll see a whole bunch of header files, .h files, and a whole bunch of functions beneath them. And there's only a couple of dozen or so here. And indeed, per this checkbox at the top, frequently used in CS50, we have sort of highlighted the functions that odds are over the next month and a half, like you will probably want to use. If I turn off that less comfortable mode, there's actually hundreds of functions that come with C, and like no programmer knows all of these functions. What they do is they read the manual when they want to find some new piece of functionality. So I'm going to simplify this. I'm going to scroll down though to standardIO.h, for instance here, and you'll see more functions that we'll eventually get to, but if I click on printf, you'll see hopefully some fairly user-friendly instructions for how this thing works. For instance, under synopsis, you'll see that we tell you what header file you should include in order to use it. Below that is something called a prototype, more on that later, but below that is a description, and here is where we, the CS50 staff, have written in layperson's terms explanations of how this function works, how to use it, and so forth. But if you'd rather see what the real world uses, you can turn off that mode, and you'll see much more arcanely the original language. So in short, these are sort of like training wheels that you can turn on and off at your leisure, but ultimately, this is real-world documentation as well.
Cool.
So if we want to see something else, for instance, let me go back to the main menu. And as we'll see today, there are actually functions in a header file called cs50.h that for a few weeks we're going to lean on heavily. Long story short, it's actually kind of hard, it's annoying in C to get user input, ironically. To like get the human to type in a word or a number, like you have to kind of jump through some technical hoops to make that happen, and we'll show you how to do it like the real way in a few weeks. But for now, among the first training wheels is a CS50 library, code that we wrote that will just make your life easier. And indeed, we're going to give you access to functions that simplify the process of actually getting input from the user. So case in point, we're going to give you access to functions like getString, when you want to get a string of text from the user. A string is just text. So if you want to get one character, one word, one sentence, one paragraph, you can call a function called getString. We're going to give you another one called getInt. When you want to get an integer from the user, like 1 or 0 or -1 or anything else, you can use that function as well. And we'll see today, too, there's other functions you can use from CS50's library. In a few weeks' time, we'll take these away once you sort of don't need them anymore, and you'll see what those library functions have been doing all along for you. But for now, let's focus on this, perhaps the most useful of them, getString, and solve a problem that we did already pretty easily in Scratch. So recall in Scratch, this was a program that used two functions, 3 in fact. Ask, to ask a question of the user, say, to actually display something on the screen, and join, to combine the default of apple, banana, or in this case, hello, and whatever the human's answer was. So this made our hello program a little more interactive last time. How can we actually translate this into a similar paradigm now? So input and output is the story as always. In this case, we have arguments going into those functions. But now we're going to introduce not side effects, which is stuff that happens visually. We're going to revisit that blue circle called answer, or the blue oval called answer, that represented last week what we called a return value. And this is what many functions will actually do for us. They're not just going to display something presumptuously on the screen or play a sound or a video or something like that. They're going to hand you back virtually a value, text or integers or sounds or images that you can then do with what you see fit. So the paradigm will now have...
Yeah, this is like super basic. The very first video, he was like explaining the ones and zeros, like light bulbs and stuff. And then, yeah, I never even heard of Scratch before. He was talking about Scratch earlier. And I kind of skimmed over it. It looks like funny looking, but yeah.
is much like in Scratch, if the input is what's your name, and the function is ask, and you get back a return value of answer, we want to actually do this now in C. So side by side, what code like this in Scratch is going to look like today onward is this. Instead of using the ask block, you literally use CS50's function called getString. It takes input, so we put the parentheses on the left and the right to kind of conjure the idea of this white oval. Inside of that string, you can put a prompt, so to speak, like what do you want the human to be asked in this case. And I'm missing something still, per the placeholders here. What's missing?
Answer.
So quotation marks, so literally quotation marks on the left and the right, and I'm going to be a little anal here. I'm going to put a space at the end because I don't want to. I could, but I don't want the cursor to go to the next line.
What did he just say?
hence no \n. If I put in the right, and I'm going to be a little anal here, I'm going to put
did
a space at the end because I don't want to. I could, but I don't want the cursor to go to the next line.
God.
Hence no \n. If I want
funny.
the cursor just to sit there kind of
Yeah, you got no
blinking,
chill.
waiting for the user after the question mark, I'm just going to put a space so it will stay there for me. But this is just an aesthetic detail using the same idea as before. So that is the analog of this block, but how do I get access to the so-called return value? MIT just plopped it on the screen for us automatically. In C, we have to write a little more code to get access to that return value. And the way we do this is on the left-hand side of this line of code, we come up with a name for the return value. You can call it anything you want, but answer is a nice equivalent to what MIT did. You could more generically call it X or Y or Z, but that's not really useful. And so computer scientists, unlike mathematicians, will tend to use variables that are a little more verbose, like the word answer. But in C, it's again a little lower level. You have to tell the computer what type of variable this is going to be. So I'm kind of conflating variable and return value, but they're being used in an intertwined way. The getString function, just like the ask block, returns a value. If you want to do something with it, you need to put it in something called a variable, which is denoted in text here. But again, per last week, the computer doesn't know if it's looking at numbers or characters or images or sounds. You have to tell it as the programmer that the zeros and ones that are somehow involved here underneath the computer's hood are in fact to be treated as text, aka string. Now there's one stupid subtlety still missing from this line of code. Does anyone know, especially if you've programmed before? Okay, all of you have programmed before, yes. Semicolon. So one of the headaches of C in a lot of languages is you actually have to finish your thought explicitly so the computer knows that that line of code is done, and it's not a period like in English, it's in fact a semicolon. Now you don't use these everywhere, we'll see where you use them, but that too is a very common mistake to overlook something simple. But again, in the coming weeks, even though this might look very cryptic, with muscle memory and practice, you'll start to see these things instantly, even if for a few days you sort of bang your head against the screen, so to speak, not seeing what the TFs and I much more readily see. So let's go ahead and do this. Let me go back over to VS Code here. Let me zoom in just a little bit, and let me go ahead and do this. I'm going to get rid of my single use of printf, and I'm going to say the exact same thing. String answer equals get string, quote unquote, what's your name, question mark, space, close quote, semicolon. And now I want to print out that answer. Well, let me do this incorrectly, deliberately for the moment. Let me just say printf, quote unquote, hello answer, if I want to plug in answer and I want to add a new line at the end, semicolon. So let me try this. But there's multiple mistakes now in my code. Let's trip over them deliberately. Let me go down to my terminal window by clicking at the bottom of the screen. Let me run make hello again, enter. And oh my God, there's even more errors now than there were before. But not a problem. Let me click on this little triangle here, which is just going to zoom in on the terminal window so it takes up my full screen. And just generally, all you have to do is find a few keywords visually that give you a clue as to what's going on. Or, as before, you can always ask the CS50 duck. So here's the command I ran, make hello. Somehow that induced all of these errors. Always read them top to bottom, not bottom up. So from top to bottom, there's a problem on line 5, character 5. Use of undeclared identifier string. Did I mean standard in? No, I didn't there. And then also, like 2 errors generated, too many errors omitted. What did I do wrong? Well, it turns out what I do need to do at the top of this file, let me click the triangle to zoom back out. If I want to use the getString function to get a string.
Some madman, what? Scratch is a block program language for kids. Yeah, I saw the Scratch thing that tripped me out. Sorry, I just noticed your message. Some madman wrote Linux though in it though. Yeah. Yeah, I was just learning about the whole Linux thing earlier. Because I've used command prompt, but I don't really understand what's the difference between command prompt and Linux.
I think she just kind of missed you.
Oh.
And it has been, I think it's been a few hours. So that's probably why.
Yeah. Are you tired? Oh wait, do you got poop? Do you need a diaper? Oh my goodness, it's so nasty.
That'll be so cute.
Alright, come on.
Michael?
Yeah.
You got simple, you
like OS, like Windows or Mac. Yeah, I was doing boot.dev, and boot.dev was making, they wanted me to try Linux, which I downloaded it, but I installed Linux, but then when, I guess I also did Ubuntu or whatever the thing's called, but then whenever I installed it, I didn't set a password, so I don't know my password's supposed to be, but I can't change my password or anything, because I never set a password when I installed it, so I'm like, anything that needs a password I can't do now, so I'm just like, well, what the you know what I mean? I meant to get my water. Yeah, so I don't even know if there was a point in installing it, because now it just kind of locks me out of doing stuff. Certain things. Y'all gotta put the ketchup back in the fridge. You never put it up. Well, put it up. Put it up. You used it, put it up. It's just ketchup, dude. Oh, yeah. I was just trying to learn with it, but I don't know. I saw videos how you can like reset the password, because I literally never set a password. I just press enter, and I didn't set a password, and I don't know. I don't know if I should like try to uninstall it, or I tried to do the reboot thing where you hit the shift button, but that wasn't working. So I don't know. Yeah, I don't. That's whatever. I probably just won't use it anyways. I mean, I could just use all the Visual Studio and stuff.
I actually need to include another header file, which is probably called include CS50.h. Technically, any order is fine. I tend to alphabetize because I just know, therefore, where to look alphabetically for a certain header file. Now that that's in place, let me again run make, hello, enter, and now we're back in business. No error message, so even though you might have more errors than you have code, odds are it's just the computer is confused, and it could be something simple and an easy fix like that. So just to be clear, standard.io.h, because I'm including it, I can use printf. CS50.h, I can use getString, because the people who invented C and the people who invented CS50 wrote those two files, so to speak, respectively. All right, unfortunately, even though the program compiles, that doesn't mean it's correct. It just means it's syntactically valid. It's valid C code. If I go ahead and run /hello and hit enter now, I'm going to be prompted for my name. So I'll type it, DAVID, and notice there's a space to the right of the question mark as promised.
Man,
enter,
that doesn't even work for me.
but it just says hello answer, which of course is not the intent. I wanted to say hello David.
Compilation.
So how can we do this? Well, in Scratch, it took a couple of puzzle pieces, but it was pretty straightforward. If I wanted to say the combination of two phrases, hello and something else, I joined those two and then pass that output to the input of say. In C, it's going to be a little different here.
What's your end goal? Why Python? I mean, I'm just trying to learn coding, any kind of coding. I was messing with Python, but I ran out of the classes on the Python thing, so I started messing with C++. And then I started watching this because it was explaining a lot of the basic fundamentals, like a lot easier for me to understand in the beginning. And so I'm kind of just seeing where he goes with it. Right now he's just using C. And so while I'm waiting on the... do you want to do back end or front end or game dev? I mean, I guess just back end coding. I mean, are you learning CPP right now, sir? Well, CPP, that's C++. Yeah, I was learning C++, but in this video, he's only doing C. I'm just doing, yeah, I'm doing all the, you should go Java for backend. Yeah, I could look up a program for it because I've been using it's basically like, I mean, I don't want to. We have the internet, so I'm trying to use all my free, like, see, I started using Kodi to try to help learn C++, but it's like going really slow. You can only get so far. But and then the MIT stuff, it has a free class for Python, but I already finished what they have released on that, so I'm waiting on the next part to come out. And so while I was waiting on that part to come out, I've started working on C++ and C, but don't do C++, it's bad for backend. I mean, what is it good for? I don't even know. I just like the coding stuff, so I like doing this part of stuff. Because what the front end, I mean, I don't know. I'm still trying to grasp the whole side of this field too, but just focus on one language and you get used to it. Yeah, the Python, well, I mean, even then when I was doing Python and then I started learning C++, I mean, it's not that hard. I mean, the language is like slightly different, but not enough to like throw me off. I think all the contents are the same as long as they cover whole syllabus. Yeah, I mean, overall it's learning how to code. I mean, different languages. I mean, it is probably not the easiest to learn more than one language at the same time while I'm trying to learn it. But, I mean, I don't know. They all kind of work together in some form or fashion. So, and I'm doing the Python thing through the MIT course. But the MIT course hasn't released their next stuff yet. So that's why I kind of stopped with Python and started working on something else. Java... Let's see. JavaScript is rolling back in. Is it Java or JavaScript? Because that's what everybody was saying. Those are like very different. Java is rolling back in. I mean, I could try to learn Java. I started doing this because I like the way he was explaining stuff. But he's only using C right now. I don't know if he's going to get... Oh, see, yeah, there's Python right here. And then SQL. I don't know what all he's going to talk about because these are very small. Like, this is... He's talking about C right here for about 2 hours. And then there's another one after this where he talks about arrays. God, I don't know. Then he talks about algorithms again. And then, like, yeah, Python's 2 hours. SQL's, like, almost 3 hours. There's JavaScript down here. Yeah. Java's never died. I don't know. Everybody was saying Java's like the biggest one right now. Well, it's Java and Python, from what I've heard. Let's see. It says Python, JavaScript. I think Java was more though, but I don't know if recently because Python's been taking off like crazy. C++ is still up there. Strong position in high performance computing, game development, and system level software. SQL's for like data entry stuff. I mean, I don't know. I'm just interested in learning it all, to be honest. Whatever's useful. Rust becoming better and better for the back end. I've heard of Rust, but I don't really know anything about it. Yeah, Java's huge. Well, I'm not switching, but if I, yeah, I mean, I'm not gonna jump all over the place. If I'm taking the courses for the Python ones, and in the time that I'm taking the courses for the Python one, I'm learning, I don't know, whatever I start getting thrown at. Whatever has a good, like, learning stuff, basically. Like, whatever has good, like, courses or videos or, you know, I mean, I'll learn anything as long as it's out there where I can access that information, basically, the best way. Yeah, I don't know. A lot of people say a lot about C++, so I don't know. I hear about C++ a lot. It's definitely one of the top ones, so I don't know. Yeah. Yeah, so I mean, I'm still learning Python. I just gotta wait for the next classes to release, but in that time, I might as well start learning other stuff too. I know how you can figure out a language by doing this stuff. I don't know. Because the other thing, I was using Cody too, that other website. Just search for back-end software engineering jobs in your area. Yeah, but I mean, are they gonna pay me to then start learning the most paid and used ones? Oh, yeah. Yeah, the most used ones, yeah, for jobs in my area are Python's a big one. And, well, I mean, really, there's like IBM's like down the road, and they're hiring like entry level back end, and that they said they just need you. At least what it says on the website is they just want you to know one language, and as long as you know one language and you have one language down, then they'll work with you. Don't fall for the go long problem. I don't know what that is. Propaganda. Go long propaganda. Start learning the most paid and used ones. Yeah, it's definitely not smart to waste your time in like the ones that aren't being used. But yeah, that's why I started with Python too, was because that's the one everybody's asking for. Java is a big one that everyone's asking for. Python, I see C++ on certain ones, but it's definitely like C++ is up there. But I think Java, Python, and SQL is asked for a lot. I mean, The math that I'm good at is kind of different. So the math that I used to do was I used to work in the oil field, and I was a driller, and so I had to learn like well control calculations, like if I show you what I was working with stuff that I was having to calculate volume and pressure. That's what I'm used to. That's what I was good at math. I'm good at math when I know what I'm doing. But, when it's something new, I have to learn it. So it all just depends. But yeah, this is the kind of stuff, this ain't with, kill sheet. I'm trying to find the right one because these are a bunch of old ones. These aren't even up to date. Yeah, see, I had to learn stuff like this. I remember this. Tab. See, I had to learn stuff like the driller's method and the weights method. These are ways to kill a well if you got like too much gas coming up. And you have to do a bunch of calculations for it. There's different ways where you can do it, where you can shut down drilling operations and you shut the hole in, and then you build heavy enough mud that's heavy enough to equalize against the pressure that the gas is pushing up, and then you pump it down, but you have to calculate at what part of that well does it need to maintain at in order for it to hold down the pressure, versus like other ways is just, typically you just raise your mud weight. But then when I started getting towards the end, we were using less mud weight to kill the well and more just back end pressure. That's what, like this, we had a drilling choke. It's a lot, but it's 2 times more than a front end. Machine learning or AI. There's applied mathematics and core pure mathematics. Yeah, see, when I was a driller, I was making 6 figures. I was making over $10,000 a month. But I can't do that anymore because it's, I got in an accident and now I have, I can't. I get dizzy is all when I stand up, so I have to like find a desk job. Starting price for 300,000. Yeah, I didn't make 300,000 a year. I was making like 120, 130, depending on like if I was trying to work overtime. But you have to be very good. Yeah. Well, shit, I don't know. That's why I'm trying to do it, because I'm trying to find, trying to get into something else. And I always wanted to get into coding, but I never had the chance to go to school. So I just went in the oil field, and I moved up in there. And then, the only reason I got out of the oil field was because kids and stuff, and the oil field keeps you away from home. But, I was good at that, but I got I was a driller, and I broke a record for one of the companies. They gave me this little belt buckle, because I broke a record, like most feet drilled for the company or in that lateral section, or not lateral, horizontal. Am I saying that right? Oh, the vertical section, my bad. But at least I was good at what I was doing. So now, if I just feel like, if I could be that good at one thing, then I can be good at another thing. It's hard to get hired if you're average, yeah. 2 to 2.5 years of grinding, yeah. I mean, if I can just get into it somewhere, I need an entry point is what I need. I just need enough to get me in, and then I can study while I'm doing it. Because, you know, like when you're doing it, especially for a living, then that's when it really starts clicking. And, yeah, I mean, I just got to get into it. Why don't you try Free Code Camp? I don't know. I've been trying all the websites, honestly. I don't know Free Code Camp, but... I'll just put it in here. Do they have like a limit on how far you can get in it? Oh no.
Dado doesn't want interruption.
Oh no.
Oh, she loves you. I love you, Olivia. Huh? I think she said no, love me.
Oh, that says it's in development. It's infinite, I think. Yeah, that's what I've been working on, like all the trying to use all the different ones. Trying to figure out. Well, I'm already working on the Python one. I don't know if I should. Well, there's this one. Free Foundation C+ with Microsoft certification. Don't do that, just do a language. I can send you a backend roadmap to know what to learn. Yeah, that'd be cool. I tried to click on the backend thing right here, but it says that they're still working on it. It's not available yet. But they got JavaScript. The Python I'm still working on. Relational database. I don't even know what that is. But there's the C hashtag, however you call that. Don't just find the right language. You know about matrix? I don't know what any of those words are. Matrices, determinants. Yeah, I mean the math and coding is different than what I'm used to. I mean, I'm used to calculating like pressure and volume and like hydrostatic pressure. Type roadmap and you'll get a list of all the topics you have to do. Roadmap and what? And Google or what is this? Oh. This one. Oh. That's all. What?
This.
What are you doing?
This.
Why are you running?
Because and this.
I don't understand.
This. My feet.
It says JavaScript, Python, Java, PHP, frameworks, Next, Django, Spring Boot. I don't know. It's a bunch of stuff. Oracle, MySQL, database, APIs, tools, Visual. I'm using, Visual Studio. Not here. Go to the first website. JavaScript, Python, Java, PHP. What's with the alternative option? Personal recommendation. Okay, so personal recommendations are JavaScript, Python, and Go. And alternative options are a lot of other things. MongoDB is for Python. So it's pig backend language. Don't do go long, however you say that, whatever you do. All right. I don't know. I don't know anything about it. Probably only do the big ones. Yeah, I don't even know. I haven't heard of it. I mean, this thing says the backend language, the best ones are... Oh, is Go the Golang one you're talking about? Is that what Go is? Yeah, that's what that is. Is that a Google one? Yeah, it's Google's static stuff. Yeah, that's Google stuff. It says JavaScript. I thought JavaScript wasn't supposed to be like for that. I got JavaScript on here, but I mean, shoot, that's what he's gonna go over JavaScript's down here. So I mean, I feel like, I don't know, if I at least get through all this, it'll teach me a lot. Maybe even teach me where I want to go with it. And it is JavaScript, isn't it? Because it says it here, like, but I don't know. The only thing I've heard about JavaScript is that it's like for small stuff. Like, I don't know. I don't really understand it. Not playing. I don't know, man. I'm still learning about it. I'm trying to get all the information, honestly.
No.
See.
It doesn't fit.
Here, I'm gonna go ahead and save this and bookmark this one.
Michael,
Huh?
I'm gonna move so Olivia doesn't mess with it.
What? Oh my god, your mom should use this.
It don't fit.
Always lighting the stupid
Don't fit.
incense.
It fit. It fit. It fit. My cover, mine. Yay, my
Okay.
cover. I want.
Alright, come on.
I'll pick. Ah,
Come on.
I'll pick. Hello.
No, Mama wants that. Oh, you don't have anything. Alright, come on. Here. AI is bad at coding. Well, the AI is currently better at coding than I am, so I'm trying to get better. Yeah, we'll place front end, huh? Yeah, honestly, well, that's why I started on this video, because I've been learning the Python stuff, but I noticed, I mean, there's a lot of information I just didn't get because I just went straight into trying to learn the Python stuff. So that's why I went back and started watching these videos. Obviously, it's really hard for me to learn stuff around here, but I'm trying. Yeah, I heard about Node.jsa. Yeah, that's a good point. That's what I was hoping to find out, because I know all the languages. The reason there's different languages and the reason people use different languages is different languages work better for different things. What? Oh my god, then go throw it in the trash. Why? Oh my god. Oh, it's a crazy world over here. Okay, well, I'm gonna get back to this, because this is like the introduction to everything, and maybe it'll give me a better understanding of it. I mean, he's already teaching me stuff, and a big part that I came in here is because Python doesn't use arrays or whatever, and I didn't know what arrays were, and I saw another video, and so I started kind of diving into this, and I was like, maybe I should learn some of the other languages, because there's a lot of things that Python doesn't do that the other languages do that I don't understand, and maybe I should be understanding that. Well, yeah, I mean, I'm still gonna, but I mean, I need to learn the basics either way. I mean, I'm still gonna, yeah, if I'm gonna commit my time into anything, I'm gonna commit it into the stuff that's being needed for actual jobs, but I still gotta learn the basics, so. I mean, that's what this video is, and this is a 2025 video, and he touches Python, SQL, JavaScript, HTML, you know, CSS, I don't know what that is. But yeah, I mean, he even talks about AI, like, I mean, so, I mean, this is a good, like, free little thing for me to learn, so that's kind of what the styling of webs. Yeah, I think I've seen, like, a picture of it. It's tied in with that whole C family, right? Like C++ and the C hashtag thing and everything.
I love you.
I love you too.
And I eat the whole egg.
You ate the whole thing? Mm-hmm. You ate the yellow part? Mm-hmm. It's called the yolk.
I know.
Oh, that's good for you.
I know.
Okay. Alright. Yeah, John Barney specific. Well, yeah, because from what I've seen is, as long as you can learn one language and get one language down really good, from what everybody's been saying, that the biggest part is getting it down and understanding the whole part of it, even if you only learn one language. If you know and understand one language and you can work with one language, it's easier to transfer those skills over to another language. But if you know a small little bits of a bunch of languages, then you don't get the full concept. So it's better to be fully knowledgeable on one language than it is to be kind of a little bit knowing on all languages, I think. I don't know. That's at least what I was seeing in videos and stuff. But yeah, I know you don't want to get totally locked into one language too, because then if you get stuck on one language, it kind of makes it difficult for you to break out of those habits of that one language. That's why I was thinking about, like, while I have the free time, start messing with some other languages. But I mean, either way, I'm at the beginning of it, so I mean, I can't really go wrong as long as I'm doing something. But I'm gonna go ahead and start this video though. I don't know how much he's gonna be talking about this kind of same stuff though, but I might start skipping some of this. I don't know.
It's an old language, and this is how it's done. Still use printf, because that's the same thing as say. I got my parentheses, I got my semicolon, good to go. But inside of that, this is where printf is different. If you want to say something followed by something else, in the world of C, you tend to use placeholders. So you don't just join things together, as we will do in Python and other languages. You say to the compiler, give me the word hello, comma, and then something else. And the %s means put another string here. It's sort of like leaving a placeholder in your code or a template where you'll actually plug in some values. Now, if this is what I want to display, I still use my quotes as before, and I might in fact have a \n if I want to move the cursor to the next line. But this is where printf is a little different. Unlike say, which took one input, printf is kind of like join. It can take 2 or more inputs if you so choose. You just have to separate them with a comma. So much like the join block has 2 ovals here that are initially white, apple, and banana until we dragged and dropped answer on top of it, printf, and really any function in C, if you want to pass in multiple inputs, that's fine. If they're supported, just separate them with commas. Here. There's no multiple parentheses, there's no multiple ovals, just separate them with commas. And now notice a potential point of confusion. What's different about this comma and this one, just instinctively? Sort of minor detail, but important. Yeah. So one is inside, one is outside. So the one that's inside the quotes is literally the English grammatical comma that you want the human to see. The one out here is a C thing that's separating the first input to this function printf from the second. Strictly speaking, you don't need a space there, but it's good practice stylistically to separate your arguments with single spaces, just as I've done there. So let me go ahead and now do something with this. Let me go back to my C code here. I'm going to clear my terminal window just to get rid of that distraction. And now I'm going to change answer to %s. And then outside of the double quotes on line 7, I'm going to do comma, answer. And then after it auto-saves, I'm going to go back to my terminal window. And just to make another deliberate mistake, /hello, enter. What's your name? David, enter. It's still broken. But why? I still have to recompile it. So again, you just get into the habit when you change your code, you have to recompile it so you get new machine code in the file hello. So let's do it again. Make hello, no errors is good, /hello, enter. What's your name again? D-A-V-I-D. And now, hello, comma, David. So again, a lot of this is still cryptic, but it's going to start to follow patterns like this. Functions like in math class f of x are written function name, parentheses, input, comma, input, however many you have. They're going to follow these patterns. But notice too, on lines 6 and 7, I have finished each of my thoughts with a semicolon. So what are the other commands that you can run in your terminal window besides something like ls? Well, it turns out there's a whole bunch of them. ls, of course, was simply short for list, which shows you the files in your current folder. But there's also cd for change directory, which is the command equivalent of like double-clicking on a folder to open it up in a graphical environment. There's cp, which is short for copy, which allows you to make a copy of a file or a folder. There's makedir, mkdir, which is short for make directory, which is how you could make a new folder. There's mv, which is short for move, which would allow you to move one file or folder from one place to another, or simply rename one of those to a different name. There's rm, which is short for remove, and there's rmdir, which is short for remove directory. So in fact, let's play around with a couple of these. Let me go back to VS Code here. One stupid subtlety still missing from this line of code. Does anyone know, especially if you've programmed before? OK, all of you have programmed before. Yes. Semicolon. So one of the headaches here, it's sort of like leaving a placeholder in your code or a template where you'll actually plug in some values. Now, if this is what I want to display, I still use my quotes as before, and I might in fact have a /n if I want to move the cursor to the next line. But this is where printf is a little different. Unlike say, which took one input, has 2, but important. Yeah.
I don't know what this terminal they're using.
So one is inside, one is outside. So the one that's inside the quotes is literally the English grammatical comma that you want the human to see. The one out here is a C thing that's separating the first input to this function printf from the second. Strictly speaking, you don't need a space there, but it's good practice stylistically to separate your arguments with single spaces, just as I've done there. So let me go ahead and now do something with this. Let me go back to my C code here. I'm going to clear my terminal window just to get rid of that distraction. And now I'm going to change answer to %s. And then outside of the double quotes on line 7, I'm going to do comma, answer. And then after it auto-saves, I'm going to go back to my terminal window. And just
Oh
to
my
make another
God.
deliberate mistake, /hello, enter. What's your name? David, enter. It's still broken, but why? I still have to recompile it. So again, you just get into the habit when you change your code, you have to recompile it so you get new machine code in the file hello. So let's do it again. Make hello, no errors is good, /hello, enter. What's your name again? DAVID. And now, hello, comma, David. So again, a lot of this is still cryptic, but it's going to start to follow patterns like this. Functions like in math class f of x are written function name, parentheses, input, comma, input, comma, input, however many you have, they're going to follow these patterns. But notice too, on lines 6 and 7, I have finished each of my thoughts with a semicolon. So what are the other commands that you can run in your terminal window besides something like ls? Well, it turns out there's a whole bunch of them. ls, of course, was simply short for list, which shows you the files in your current folder. But there's also cd for change directory, which is the command equivalent of like double-clicking on a folder to open it up in a graphical environment. There's cp, which is short for copy, which allows you to make a copy of a file or a folder. There's makedir, mkdir, which is short for make directory, which is how you could make a new folder. There's mv, which is short for move, which would allow you to move one file or folder from one place to another, or simply rename one of those to a different name. There's rm, which is short for remove, and there's rmdir, which is short for remove directory. So in fact, let's play around with a couple of these. Let me go back to VS Code here. Let me go ahead and open up my File Explorer and recall that at this point I've got two files, hello.c, which contains my source code, and then hello, which contains my machine code, the executable program that I previously generated by running make. Well, let me go ahead and propose that I'd like to prepare to keep all of my files and folders very orderly. So if like for every program I write or for every problem on a problem set I write, maybe I want to store my relevant files in a specific folder for that problem. So suppose then that I want to put hello.c in a folder, otherwise known as a directory, called hello. Well, I can't do that quite yet because I already have a program called hello, so let me use one of those new commands. rm space hello will delete or remove hello from my current directory. So I'm going to hit enter. I'm going to be prompted to confirm with Y for yes or N for no, remove regular file hello. I'm going to hit Y and enter. And as I hit enter, watch the top left of my screen as the hello file would seem to disappear. Voila, it's now gone. So now I'm going to go ahead and use a different command. Let me go ahead and do mkdir for make directory. I'm going to call the directory itself hello and watch again at top left what happens. Enter. Now I have not a file, but a folder called hello. And in this GUI, the fact that it's a folder is indicated, 1, by its icon, and 2, by that little right-facing triangle, which means I can expand it to see what's inside. And in fact, if I do that, I'll see, of course, that nothing's in it because we literally just created it. All right, well, what if I want to move hello.c into the new hello folder? Well, I could, just like on Mac OS or Windows, I could actually, in my File Explorer, click and drag one into the other, but let's do this entirely within the terminal window. So let me do this. Let me move, or MV for short, my file called hello.c into a new destination folder, hello. And I can optionally put a slash at the end of hello just to make super clear that it's a directory, but that's not strictly necessary. But if I say mv hello.c hello with spaces in between, assuming hello exists as a folder, watch what happens at top left now. It's a little more subtle, but hello.c is going to move inside of the hello folder right now. And indeed, it's only slightly more indented, but notice if I collapse the hello folder, notice that it seems to be gone because hello.c is now inside of that folder. Of course, if I expand that, I'll see it again. If I go back to my terminal window and type ls for list, now I don't see hello.c, and I don't see an executable program anymore, but I do see hello and the slash. Yeah, a really good question. If we had something other than a string of text, and we had an integer, would you still use %s? No, you would use something else. And indeed, %i is what we're going to use, and we're going to actually do that. Perfect segue to other types that C actually has. So up until now, we've been calling a string of text literally a string. And this is common in many programming languages, including Python and JavaScript. Strings in the programming world just mean text, whether it's 0 or more characters thereof. But C does have other data types, just a few of which we'll dabble with today, but you'll use more over time. We've already seen string, for instance, which is indeed a string of text, but let's focus as well on like an integer. As an aside, there's other types too. There's Boolean values, like true or false. There's chars, which are single characters instead of full phrases or sentences. There's doubles and floats, which are real numbers, something with a decimal point, the equivalent of fractions. And there's longs, which are integers, but like longer integers, even bigger integers than you might type by default. So let's focus on an int, because so many computer programs, of course, manipulate numbers in some way. So what can we do with this? Well, if we want to be able to get an integer, lucky enough, CS50's library comes not just with getString, but also getInt. So that's going to be a third function we now use in C. And we need to know these, what were generally called format codes. So that placeholder I called before %s is indeed for a string. If we want to place an integer inside of something we're printing to the screen, we are in fact going to use %i instead. So let's now actually use these building blocks, getInt and %i, to actually get numbers in some way to sort of solve a problem. Well, what problem could we solve? Let's introduce another concept from scratch and programming more generally known as conditionals, like those proverbial forks in the road. If something is true, do this, else maybe do this other thing. So in Scratch, we might have had a set of puzzle pieces that looked like this. If x is less than y, then say, or have the cat say, x is less than y. So it's sort of stupid program, but it just demonstrates how we have two variables, x and y, in the context of Scratch. We're comparing them with a Boolean expression. We're using a conditional to then conditionally say or not say this phrase here, depending on whether this question has an answer of true or false, yes or no. In C, it doesn't look all that different. It's a little more cryptic, but you say literally if. You use parentheses, similar to functions, but confusingly, by convention, you put a space after the word if. So you don't put spaces after function names. You do put spaces after words like if. And you use the parentheses to conjure up this weird trapezoidal-like shape. So there's no real keys that kind of conjure that. So C uses parentheses, like most languages. And then there's these weird curly braces, which at least in English, we don't use all that often. But they're there on your keyboard, English or otherwise. And they essentially allow us to create this sort of hugging shape to the puzzle piece. Anything inside of those curly braces is going to be equivalent to anything inside of this yellow hug that's sort of grabbing one or more pieces inside. So what do we put inside? Well, this part is straightforward. Printf, quote unquote, x is less than y, \n, semicolon. So nothing new here. The only bit of new code is this if construct instead. What if you have an if-else, so a two-way fork in the road? This is what that looked like in Scratch. Same question, if x is less than y, then say x is less than y, else say x is not less than y. In C, the code is going to be set up initially like this. So two sets of curly braces to represent this pair of yellow bars and this pair of yellow bars. And what's inside of them, indented no less, just like our pseudocode last week, is two printfs. X is less than y, x is not less than y. So that's it. So the only new stuff here really is now the else keyword, which does not need parentheses because you're just saying else do this other thing. But what if it's a three-way fork in the road? And we'll stop after that. Here's a three-way fork in the road in Scratch. If x is less than y, then say this. Else, if x is greater than y, say this. Else, if x equals y, then say this. So this is a little more precise because now we're handling equality, not just greater than or the opposite. In C, it's going to look similar to before, but we're adding this element here. And at first glance, especially if you've never programmed before, it looks like I'm an idiot and I made a typo. What looks wrong? There's like two equal signs, like not a typo. So it turns out, recall from earlier, when we used the equal sign the first time around, we used it in the context of getting a return value back from a function, like the getString function handed me back the user's answer. So unfortunately, because humans decades ago decided, hey, let's use the equal sign to assign a return value from the right-hand side of a line of code to the left-hand side, we sort of painted ourselves into a corner and like, oh shoot, what do we do when we actually want to test for equality of two values on the left and right? So what most languages, including C, do is use double equal signs. So you can say double equals or equals equals or whatever, but it is in fact syntactically correct. What's inside of these three sets of curly braces? Same idea, printf, 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 based on what English phrase you want to print out. So this code, both in Scratch and C, I'll claim is correct. It won't run because we still need like the other stuff, the equivalent of the when green flag clicked. But out of context, this code is correct. But there's a subtle weakness in design. And we'll talk a lot about this week and beyond. Correctness just means the code does what it's supposed to do. Design is more subjective, like how well have you written your argument in an English paper? How well have you written your code is design. This code is not designed as well as it could be because I'm doing more work than I need to. Yeah, and back. Yeah, I don't need the x equals y, but why, logically? Exactly, that's just a math thing. Like either x is less than y, or it's greater than y, or the third and final option is they must be equal. So it's subtle, but why would you bother wasting time writing a line of code and expecting the computer to run a line of code that is just going to answer a question that logically you could have concluded already? Because if x is not less than y, and x is not greater than y, then my God, just print out x is equal to y, because you know at that point, logically, it's true. You don't need to waste your time or the computer's asking a third question unnecessarily. In reality, it's not a huge deal. No one's going to notice in the real world on a Mac or PC that there's this extra line of code, but it's a bad habit. Keep it simple. Don't write code that doesn't need to be there if logically you can conclude otherwise. So in fact, let's clean this up both in Scratch and in C. I can tighten this up, so to speak, use less code here, less code here, and honestly, if only statistically, the less code I write, the less likely I am going to make mistakes, so that too is probably a net positive overall. Writing less code is generally better than writing more code, not unlike English essays too, perhaps. All right, questions about this feature of C, conditionals, and this syntax? Yeah. Oh, a really good question. And yes, jumping the gun, there are alternative ways to solve problems like these. And the question was, to summarize, when to use if, else versus what's called a switch statement. More on those another time. But this is going to be true in general in programming, not just C, not just in Scratch, but every language. There are going to be several, dozens, hundreds, an infinite number of ways to solve problems. Among the things we're going to teach you, though, is indeed how to do things well or better than you might otherwise. And we're going to introduce you eventually to another feature of the language that can even simplify this code too. So for now, let's actually use this then. So let me go over to VS Code again. I'm going to go ahead now and clear my terminal window. Down here, I'm going to go ahead and close the hello.c tab, just so that we're going to create a new program. And let's just do something a little simple using some operators, so to speak. And I haven't used this word by name, but it turns out that there's lots of operators that come with C, just like a lot of operators that came with Scratch for doing assignment, or less than or equal to, greater than or equal to, actually equal to, not equal to. Now, some of these are a little cryptic, but there's no easily found key on your US English keyboard, at least, where you can do less than or equals or greater than or equals. So what most programming languages do is you don't use a special symbol where there's like an angled bracket and then a line below it. You actually just use two characters. So greater than or equal is literally this. Less than or equal is literally this. We already saw that equals is this. And not equals is to use an exclamation point. So this too is a thing in programming. Using the exclamation point, pronounced bang, is how you invert logically certain things. So bang equals or not equals is how you would express exactly that idea. It's just a symbol on the keyboard that some human decided, let's use this one to invert the idea. But we're going to need one other thing for this program, specifically variables, which we've used already sort of because in Scratch we got one for free. We had that answer variable that stored the return value of the ask block. But let's consider in general how you can, and probably did for problem set 0, use a variable of your own, like keeping track of a counter or a score or the like. In Scratch, if you want to create a variable called counter, you can set it equal to some initial value like 0. How much easier it is to write code. Because I wrote this code top to bottom, this question is going to be asked no matter what. The answer is terms and conditions. Else, if C equals lowercase n, go ahead and print out, for instance, not agreed, just so we see something on the screen. So let me hide my terminal window and focus on the code. There's a couple of details here that are a little interesting. So one, what did I do on lines 7 and 11 that is not consistent with what I've done before? Subtle. So I'm using apostrophes or single quotes now. Factoring out some commonality, you should do so, similar in spirit to math, when you factor out variables or the like. So let me tighten this up, so to speak. Let me get rid of what we just did so that it's a little shorter as before, and let me express myself with two conditions using the following syntax. I want to check if C All right, let's do one final set of examples before taking a cookie break, if we could. But let's go ahead and close agree.c here. Let me open my terminal window, and let's go ahead and implement a sort of virtual cat as we did last week. I'm going to code up a file called cat.c, and I'm going to implement this in a few different ways, the first of them pretty foolish. So here, I'm going to include standard.io.h, no need for CS50 just yet, int main void. Inside of these curly braces, let's go ahead and do printf meow to get the cat to meow. And then to save time, I'm going to copy paste that 2 more times. So this cat shall meow 3 times in total. All right, I'm going to go ahead and make the cat, so to speak. All good. /cat, enter, and it meows 3 times just like our scratch cat last time. I'll stipulate this is correct. This is a really well implemented cat correctness-wise, but why is it bad design intuitively, just like last week? Sorry? I keep repeating the code. I mean, I literally copied and pasted, which is sort of your first obvious sign. I'm probably doing something wrong if I'm copying and pasting, because I'm literally repeating myself. So to spoil it, like odds are a loop is probably going to be our friend here. And so in fact, in C, we have those features as well. So in the world of C, we can implement some of last week's same ideas in a few different ways. These are a little more mechanical, but suppose we want to repeat something literally 3 times. Scratch gives us a repeat block with an input, so easy. C, and a lot of languages, it's going to be a little more mechanical. And it's going to look ugly at first. It will take some getting used to, but it is a paradigm you will use again and again and again. This will become very rote memory before long. Well, the most direct translation of this Scratch code to C is probably in decrement I, and then do this whole thing again. Now, I could have called this variable counter for consistency with earlier, but it turns out it's conventional when you've only got one variable involved in your code and all it's doing is something simple like counting. You can go ahead and call the variable I for integer, for instance, but it would not be wrong to instead call I counter. But notice, too, that in this so-called while loop, as we'll start to call it, there is this parenthetical. And that parenthetical is actually itself a Boolean expression. But unlike an if statement, whereby the Boolean expression is evaluated just once, and if the answer is true or yes, you do that thing, the Boolean expression in a while loop here in C is evaluated again and again and again every time you go through the loop to check if you should keep going through the loop. So for instance, if the goal at hand is to say meow, well, of course, the comparable C function is going to be printf, and I want to print out on the screen meow, followed by a new line. Well, what's going on? Well, again, I initialize I to 3. I then check, is I greater than 0? And of course it is, because effectively in the computer's memory, 3 fingers are up. I go ahead and print out meow. I decrement I, which means to put down one of those fingers, and then I check the Boolean expression again. Is 2 greater than 0? Of course it is, so I print out meow, and then I decrement I, putting down one more finger. Then I check the expression again. Is 1 greater than 0? Of course it is. I print out meow, and then I decrement I, and now I'm down to 0. I check again. Is a 0 greater than 0? Well, no, and so the loop will automatically, by the definition of how this C code works, terminate for me and proceed to any other lines if there are more lines of code that I've written. So how do we actually implement this then in code and get it running? Well, it's going to be pretty much the same idea. Let me go back to VS Code here. I'm going to get rid of all of this copy paste, and inside of my main function, I'm going to do exactly what we saw. Int I equals 3, semicolon. While I is greater than 0, then go ahead and print out with printf, meow, \n, and then be sure you decrement I. And notice that lines 8 and 9 are not only indented, they are inside of that while loop, so to speak, which means they will both happen again and again and again, because what's happening in code here is those curly braces are kind of like the yellow pieces that are hugging the other puzzle pieces in Scratch. It will keep doing this, 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 but every time through that loop or cycle, this Boolean expression will be checked again and again and again until the answer is false, at which point the computer is going to jump to the last line, and if there's nothing left, that's it for the program. No more to be done. So same exact idea in Scratch, even though it's a little more mechanical, so that's how we might implement this. And you can think of it sort of, these variables, this is perhaps a little gratuitous, but let's do this. So if you have a variable inside of a computer's memory, and that's a detail we'll get to in more detail before long, you can really think of it just as like a container that stores value. So for instance, clear plastic bowl, it can be thought of as a variable. It just stores values. And right now there's obviously 3 stress balls in it, so it represents the number 3. So what's really happening in code like this is we've initialized I to 3, which is this bowl. We're then checking the question on line 6, is I greater than 0? Obviously. So we proceed inside of the curly braces and we print out meow. We then decrement I. So for the sake of unnecessary drama, like that's decrementing the variable. So what's being stored in this container now is 1 less. We do it again, check the count. Nope, 2 is greater than 0, so we keep going. Meow, decrement I. Check the variable. 1 is greater than 0, so we print meow, decrement I. We check the condition again. I is not greater than 0 because 0 is not greater than 0. And so the rest of the code stops executing. I'm not sure if that was any more effective than fingers on my hand, but we had the ball, so same exact idea. Variables are just storing some value, and incrementing and decrementing would just be adding or subtracting stress balls in this case. But there's other ways we could do this. In fact, let me zoom in on my code here. And it's not really conventional in programming to count down. Like, nothing wrong with it. It's just not really a thing. We would typically count up. So we could alternatively do this. Set I equal to 1 initially. So we count 1, 2, 3, like a normal person. And we can change our condition. If I'm going to count from 1 to 3, what should my comparison be in my Boolean expression here? I is less than 3? Less than or equal to 3, I think. So if I is initialized to 1, we're going to go through this 1 time, 2 times, 3 times. I is going to eventually get incremented to 4, but at that point, 4 is not less than or equal to 3, so it's only going to execute a total of 3 times. But there's still a bug in this code. What other line needs to change? Yeah, so line 9 needs to become plus plus. So this code is just as correct, and honestly, reasonable people will disagree. Your TF might say do it this way and not this way, but like this is still correct, but it's not the most conventional way. As per last week, computer scientists and programmers generally actually start counting from 0 by convention for reasons we'll soon see. So the better way, the more conventional way, arguably, would be always start counting from 0, count up to, but not through the number you care about. And so this form of the code is probably the most popular way to do it. Start at 0, count up to 3, but not through 3, as with less than or equals than. All 3 are correct. Can't really do counting up as easily with the bowl without picking up the balls, but the exact same logic applies. And in fact, this version of the code is so commonly done that there's a different way to implement it all. There's a similar way to implement it all together. In fact, this code here, same exact thing, repeating 3 times, because it's so commonly done that you want to initialize something to 0 and keep doing something until like the value 3, you can actually use a different preposition for, which is another keyword in C, and it looks a little more cryptic, but it just tightens things up. This is what's called a for loop. Previous is what's called a while loop. And honestly, even though it probably to the newbie still looks just as cryptic, it's just a little tighter because you're expressing all of these ideas on one line. You specify the variable you want to create and initialize. You specify the Boolean expression you want to check again and again. You specify what increments or decrements you want to happen. And confusingly, you do use semicolons here, not commas. You do not put a semicolon here. You, of course, don't put them after these things. You generally only put them after functions thus far. So we do have one semicolon here. But in short, this you'll get more comfortable with. This is how I, for instance, almost always write a loop, but it's doing the exact same thing mechanically as this. Same thing as counting on your fingers. Same thing as counting the stress balls. There's just different ways to express the exact same idea. But there are ways to screw up. So in fact, let me go ahead and do this. Suppose that we'd like the cat to live as long as possible, and we don't want it to stop meowing after just 3 or a finite number of times. How can you do something forever, again and again and again? Well, let me go back into VS Code here. Let me delete all of the code from earlier. And let me go ahead and say, while something is true, I'll come back to that. Let's just go ahead and print out meow, \n, ideally forever. But what do I want to put in here? Well, if I want to do something forever, I could do something kind of stupid like while 1 is less than 2, which is always going to be the case. Or while 50 is less than 51, which is always going to be. I could just ask an arbitrary question, but like arbitrary, not good in general. Like you should have meaning behind your code. So if you want the expression to be true all of the time, just say while true, because true is not changing anytime soon. If it's literally true, it's always going to be true. The only caveat is to use this trick for now. You will need to include the CS50 library, which for today's purposes makes that possible. But there's a problem, of course. If the cat's going to live forever, if I do make cat /cat enter, like you can very quickly lose control over your terminal window, and you can see like the meows are flying across the screen, at least based on the bottom from what we're seeing. Like this cat will never stop meowing, and this is either a feature or a bug, so to speak, depending on how long the cat here should live virtually. But how do you terminate a program that is out of control like this infinitely? So one of the takeaways for today is Control-C is your friend for cancel or interrupt the program. If you ever sort of lose control over a program because you've got intentionally or unintentionally an infinite loop, you can go into your terminal window, hit Control-C, sometimes multiple times if it's ignoring you, and that will break out of the program and just essentially force quit it, like in Macs or PCs. But let's make one improvement here still. The last thing we did with our cat in Scratch, before now we'll take a break in a moment, was we defined our own functions. And recall that we did that to abstract away the idea of meowing, because Scratch didn't come with a meow puzzle piece. C definitely does not come with a meow function. We have to implement it ourselves. So quickly toward the end of week 0, we did this. Define a function called meow that just plays the meow sound. And now we have a meow puzzle piece we can use and reuse. In C, we're about to do this. And this is going to look a little cryptic, but it's going to lay the foundation for future weeks when we do this even more. I've got a meow function. Weird mentions of void. That just means there's no input and there's no output for this function. It just does one thing simply, and that one thing is printf meow. So how do I use this here code? Here in Scratch is how we used it last week. When the green flag is clicked, repeat 3 times the meow function. In C, it's going to look like this. Int made void and all of that. And I can use a for loop, a while loop. I'm copying and pasting the for loop version of the code. Set I equal to 0. Make sure it stays below 3. Increment it on each iteration or cycle, and just call meow. So what's nice here is that we have fairly simply a way in C to create our own functions called meow or anything else that lines up perfectly with what we did in Scratch. We'll take some time to get comfy with the syntax and remember it, have to look it up frequently for reference, but let's go ahead and actually do this. If I go back to VS Code, clear my screen, let me hide my terminal window temporarily, let me go ahead and invent this meow function. Per the code earlier, I'm going to go ahead and do this. Void, meow, void. And again, the 2 voids mean no input, no output. It just does one thing well. Printf, quote unquote, meow, \n. And now down here, I can use a for loop. So for, and I know this from memory, int I equals 0, I less than 3, I plus plus. And then inside of curly braces, I'm going to go ahead and call the meow function. Notice, when I'm creating the function up here, I explicitly, pedantically say void, void, no input, no output. When I use the function on line 13, you just say open parenthesis, close parenthesis. That's the equivalent of a Scratch puzzle piece without a white oval. You just put nothing there. You don't put the word void. So that's it. Let me open my terminal window. Let me run make cat to rerun or to recompile /cat, and I think I have a working cat. Now this is correct. The only thing I don't love about this version, if I hide my terminal window, is that when I start writing bigger and bigger programs, it'd be nice if my main function, which I told you to sort of take on faith for today, is at the top of the file, if only because, like, literally the name main means this is the main part of my program. It'd be nice if it's the first thing I see. Which is to say, just to be pedantic, it's very common to put any functions you write at the bottom of your file, maybe alphabetically, maybe organized some other way. But you put main first by convention, just like the when the green flag clicked was the first thing you always started with last week.
Hello? Hey.
But watch what happens now. If I go into my terminal window, and Command or Control J is hiding and showing it if you are curious, but probably you'll just leave it open on your own all the time. Let me do make cat again. And I've screwed up somehow. All I did was move the meow function from top to bottom, and I'm getting call to undeclared function meow something, something, something. Well, what's going on? Well, C is pretty naive and simplistic. It's only going to do what you tell it to do, and it's only going to do things top to bottom, left to right. And unfortunately, on line 8, you are telling C, call a function called meow. But that does not exist in CS50's header file. That does not exist in standard IO's header file. It exists at the bottom of my file, at which point it's too late because I'm trying to use it before it exists. So I could just undo that and put this meow function at the top of the file, but you're going to eventually get into a perverse scenario where you can't put all of your functions above all of your functions. Like, you got to pick a lane at some point. So the solution to this, albeit a little weird, and the one time in CS50 and programming that it is encouraged and necessary to copy paste, is what you can do at the top of your code, be above main, is just copy paste the first line of your own function. This is the so-called prototype of the function, and it simply describes how to use the function. And funny enough, we actually saw this earlier, but I sort of, swept it under the rug a moment ago, or a bit ago, when we looked at standard.io.h and we looked at the printf function in the manual pages. I highlighted the header file, but I also glossed over the so-called prototype, which is, the first line of the printf function, just as this is the first line of my meow function. This is like a little clue. This is like saying to C, hey, there's going to be a function called meow that takes no input, has no input, takes no input, has no output. Just know that it exists eventually. And that will satisfy the compiler. Because if I go back to my terminal, rerun make cat, it now knows on faith, per line 4, this function will eventually exist. And indeed, once it gets to the bottom of my code, line 14 onward, there it in fact is. So you just copy the one and only first line of your function's code to the top, called the prototype. And now if I do /cat, I get, finally, meow, 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 yet again in this case. Let's actually move the for loop from main into the meow function, such that I now have my curly braces here. I have my print statement inside of those curly braces. And now in main, I can get rid of all of that code, just say meow any number of times, like 3. And just like I did with Scratch, let me hit enter an arbitrary number of times, sort of out of sight, out of mind. Now the essence of my program is like one real line of code, meow 3 times, because I've abstracted away the idea of meowing and told the cat instead exactly how many times to meow by way of that function. Okay, I can't keep stringing along cookies so long. Let's go ahead and take a 10-minute break here, and when we come back, more cats, more code. All right. So we are back, and want to add one final flourish to this program, because now, more so than a lot of the examples, like now the programs are starting to grow in length, and indeed soon there'll be a few dozen lines of code, which is not uncommon. But let's suppose that we want to stop hard coding 3 everywhere and actually prompt the user for some number of meows here. Well, let me do this. In VS Code, I'm going to go ahead and get rid of this one line for now, and let's do something like this. Let's ask the user for an integer. So int, maybe n for number equals get int, and we'll say something like just number to give a number of meows. And then we'll go ahead and actually call meow, passing in not 3 this time, but passing in n. So we are using the return value of get int to store it in a variable called n on line 8, and then we are passing n as the input or argument to the function called meow on line 9. And again, the actual implementation of meow on line 22 onward, like who cares, out of sight, out of mind, once it exists. We can sort of abstract it away mentally, but I'll keep it uptight here anyway. All right, so let me go ahead and open my terminal window, make cat, /cat, number. I can still type in 3 and it works, or I can go ahead and type in 5, meow, 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 but it's not actually meowing 5 times. Why? I didn't realize this either, but there's a bug. Yeah, Exactly. So the for loop, when I copy pasted it before break, I actually kind of got lazy and I forgot to change the 3 to an n so that it matches the name of the argument that's being passed into meow. So that was a bug, unintentional on my part, but we have now fixed it here, and now we are passing this in from main to meow. So if I make cat /cat and type 5 this time, I indeed get 5 meows. But it's worth noting there's some subtleties here in my code in that I've used n a couple of times. So this is actually deliberate that I've used n twice in this way to induce a bit of confusion. But it turns out this n is actually not the same as this n, nor this one. So what's going on here? Well, it turns out in programming there's often this idea of scope. And long story short, generally speaking, variables only exist in the scope in which you create them. More down to earth, variables only exist inside of the curly braces in which you define them. So for instance, suppose I got a little sloppy, and suppose I didn't bother giving meow an input, and I didn't bother giving its prototype an input, and I just used n on line 14, because why? Well, I already defined n on line 8. So this is just an alternate universe in which I'm not changing meow to take input. I'm just using n in 2 different functions. In main, on line 8 and 9, actually I don't even need that, on line 8 and 9, and also again on line 14. This code will not work. Like the compiler will not like this. Why? Because n does not exist inside of meow. Why? Per the heuristic I offered, n exists only inside of the curly braces in which it was defined, namely these curly braces here. So n is in scope in main, so to speak, but it is not in scope in meow. And that's why we kind of have to jump through these hoops and use inputs and outputs and inputs and outputs and pass things around among functions without sort of sharing things across functions instead. Now, I could clarify this and maybe change my argument here from n to like times. If I want to make clear that, oh, this is the number of times I want meow to be said, I don't have to use n for both, but just realize that if you do, it's just a coincidence. They are not usable in 2 different scopes. All right, let's do one other thing though. Let's not only prompt the user for the number here. Let's make sure that it makes sense what number they give us. So if I do make cat, just to clean things up, /cat, suppose I type 0. Okay, I suppose that's correct. If I say meow 0 times and it doesn't meow at all, that's arguably correct. But if I type in something like -5, it ignores me, which I guess is better than crashing or freezing or something. But like, ideally, it might be nice to handle this situation. And if they give me a negative number, prompt them again for a positive number. Prompt them again for a positive number. Like, make the program make sense. So how could we do that? Well, a couple of ways. If I go back into my code here, I could do this. I could maybe do something like a loop, or let's see. So if I get n, so if n is less than 1, then it makes no sense. So what do I want to do if n is less than 1? Well, I could just prompt the user again, and I'd say, okay, let's get n again. And then I can say, if n is less than 1, what do I want to do? I guess we could ask the user again. And then if n is less than 1, I could just, again, like I can give them like 3 tries, 4 tries to get this right. Like, this is obviously stupid. Like, I'm copying and pasting, I'm repeating myself. There's no end in sight. Like, I can't do this forever, surely. So this just feels like the wrong solution. So there are different ways to solve this problem. And funny enough, like a while loop is not really the best way. A do-while loop is, a while loop is not the best way. A for loop is not the best way. It turns out there's one other type of loop that we wanted to introduce that's super useful for getting user input, potentially again and again and again, so that the user cooperates. Specifically, what I'm going to do is this. I'm going to literally say do the following while something is true. So it's more of a mouthful. I'm spreading it out over multiple lines. But what am I going to put inside of the do block here? I'm going to say int n equals get int and ask for that number as before, close quote, semicolon. And I'm going to keep asking while, sorry, accidental enter, while n is less than 1, semicolon. So notice the semantics of this. Even though it's a little weird looking, it does read in English. Do the following, okay, get in int, stored in n, and keep Oh, where does that bring us? So after all this discussion of code, like at the end of the day, like this is what's important in the world of programming. Not surprisingly, it's like what's important when it comes to grading and evaluating the quality of code. One and first and foremost is correctness. Like if the code does not do what it's supposed to do, what was the point of writing the code? So correctness sort of goes without saying. Design, again, is much more qualitative. It's like getting feedback, again, on an English essay where reasonable people might disagree. You can make your argument better. You can structure the paper better. You can structure the code better in the case of programming. And style is purely aesthetic. Does it look good? Is it pretty printed, so to speak? Can other people, colleagues, future, and classmates present actually read and understand it? That's what we mean by style. Nicely enough, within CS50's programming environment, you will have tools to evaluate the quality of all three of these axes, so to speak. So in problem set 1 onward, you'll be introduced to a command line tool that you type its name at the prompt called Check50 that will check for you the correctness of your code. Not necessarily exhaustively, like there might be mistakes you've made that we don't catch, which doesn't make your code correct, but are. So the first of these programs falls into this category of having side effects. So let's implement one or more functions that takes an argument's inputs, and as its output produces these visual side effects. We'll draw inspiration from Super Mario Brothers, not surprisingly perhaps here. The original one, which was very two-dimensional, side-scroller, left to right. Mario or Luigi move from left to right, and generally have to like jump over things like pyramids or other shapes on the screen. So how might we go about implementing some of the screens from Super Mario Brothers, albeit textually? Well, we'll make it a little black and white and ASCII art, so to speak here, using just our keyboard. But suppose we want to write a program called Mario.c that just prints out 4 question marks. It's not going to be nearly as pretty as what's on the screen here, but the logic is going to be the exact same as what Nintendo presumably did years ago. So let me open VS Code, my terminal window. Let's code a program called Mario.c. In Mario.c, I'm going to kind of start with some boilerplate. I know I want to print, so even if I don't know how to do this yet, I'm going to include standard io.h. For today's purposes, I'm going to copy, paste, or type out that same line again and again, int main void. And inside of my main function, akin to the green flag being clicked, I want to go ahead and print out 4 question marks. Well, honestly, the simplest way I can think of doing this is with printf, question mark, question mark, question mark, question mark, maybe a \n to move the cursor, and that's it. So that is arguably correct. So let's do make Mario in the terminal, /Mario, and it's not quite as pretty as the game version of it, but it is in fact the exact same idea. But here's sort of an opportunity, stepping stone, to do better design. Like this game changes over time, and not all of the screens have just 4 question marks. It might be 5, 6, or even more. So what's the right programming construct with which we could generalize how many question marks are printing here? Like what feature of C do we want? Like a loop, like a for loop, a while loop, or something like that. And there's different ways to do this, but honestly, I've proposed earlier that we get into the habit of reaching for loops as just very conventional. So let's do that. For int I equals 0, I less than 4, because that's how many I want for the moment, I plus plus, and then inside of my curly braces there, let's go ahead and print out, quote unquote, a single question mark, but no new line. Let me now go ahead and make Mario, and can you anticipate a arguably aesthetic bug when I hit enter? It's not going to move the cursor to the next line, but the solution here is a little non-obvious. I don't think this helps me. If I put the \n there and I do make Mario again in /Mario, what is this output going to look like instead? Yeah, like a vertical column of question marks, which, while nice enough, is not the goal at hand. The goal is these horizontal ones. So someone else, what's the fix here if clearly putting the \n inside of line 7 is wrong? Yeah, so put it after the loop, and not after the printf line specifically, after and thus outside of the loop, so that after that loop is finished executing 3 total times, it's totally fine to just print nothing other than a \n, so long as we now recompile the code, make Mario, /Mario, and voila, now we have 4 in a row. It's a little generalized. OK, so we've sort of plucked off a fairly easy problem. Well, let's go back to the world of Mario and try something that is, in fact, vertical like this. So this is another scene with like 3 bricks here. Instead of using question marks, we'll use hash symbols to represent bricks. This actually is the incarnation of my mistake a moment ago. So let me undo this by getting rid of that printf. Let me change the inside one from a question mark to a hash symbol, which look.
Controller. Stop.
I didn't say I'm electrical.
The most similar in ASCII to a brick. And let's go ahead and put in \n after that. If I do go ahead and do make Mario, /Mario, it's not that interesting, but, and it's actually not that correct because I wanted 3, so no big deal. I can, of course, go back to my code and change the 4 to a 3, or better yet, I could use getInt or my new getPositiveInt function and just generalize this further so that I can print out any number of them. But for now, /Mario gives me 3. All right, so we've plucked off the second of 2 problems. Let's now let things escalate a bit. So it turns out once you get to like World 2 and beyond, there's some underground parts of Mario where you actually have bigger, more solid bricks like these here. And just by eyeballing it, this is like a 3x3 grid of bricks, like 9 of them total, we'll conjecture. So how can I go about implementing this? Well, now is where the program gets a little more interesting. And the sort of not correct, well, the poorly designed way to do this would be like printf ###n semicolon, and then maybe printf. Like, that's kind of like correct, but not well designed. So make Mario, /Mario. You know, it doesn't look like a square just because these hashes are more vertical than they are horizontal, but it is correct, this example. But it's not very generalizable, and this is like literally hard coding. I copy pasted. I'm just doing a lot of bad practices here. So what could I do instead? Well, it turns out we can combine today's ideas, including loops, to do things again and again. So what is this grid of bricks? It's a 3x3, so that's like, you know, it's like a row and a row and a row, and then within each row there's like column, column, column. So it too is like an old-timey typewriter that sort of prints one line, then the next line, then the next line, and so forth. So how can we conjure that in code? Well, let me go ahead and do this. I think a print approach would work is like this. For int I equals 0, I less than 3, I plus plus, because I know I want to do something 3 times. But what do I want to do 3 times? This loop kind of represents in my mind's eye row, row, row. So in fact, I could be more pedantic. If I want my I to mean something beyond int, I could say row equals 0, row less than 3, row plus plus, just to help me think about it. And then what do I want to do on each row? What do I want to print? Like column, column, column. So brick, brick, brick. So how do I print 3 bricks or any number of bricks? Well, I could kind of cheat and just do printf ###n. But again, I can't generalize. I can't take an input from the user and print 4 or 5 or 6 bricks. So that's going to get me into trouble eventually. So maybe I could use a loop. So I could do like for int I equals 0, I less than 3, I plus plus, inside of my loop, and then in here I could print out 1 hash, and that's kind of on the right direction, the right path, because now I'm just using the simple building block or brick, but reusing it again and again. And it's totally fine to have nested these columns in this way. I used I out of habit, but what would a better name be? Well, maybe column, or maybe just COL, call for short, so that my code is sort of saying what it does for me. And I don't have to use row or column explicitly. I don't need to print them, but I am using them as counters, one after the other. So let me go ahead and run make Mario, /Mario, and I'm feeling good about this, but damn it, there's 9 bricks, but they're not really laid out right. Why? What's the fix? Yeah, I never went to a new line, and let me do what I think you're not going to suggest I do. Let me just go to the obvious place. All right, well, let's put one right after the brick. But of course, if I do make Mario, /Mario, I'm making the same mistake as before. I'm printing out too many new lines. So in between what lines do I actually want to print a new line? Between, yeah. Yeah, so 10 and 11. So outside of the inner loop, but inside of the outer loop. So it happens again and again. So let's just print out as before, a single \n semicolon. Now let's do make Mario, /Mario, enter. Now it's generalized as I see fit. And if I really wanted to dwell on this, I could go in and I could prompt the user with getInt or with getPositiveInt, figure out what row and or column should be. We can make any size brick that we want, but now we have sort of a nice starting point. But there's another way to think about this, because I dare say, especially for like your first CS50 problem set, if you're trying to print bricks in the world of Mario in this way, it's probably not going to be obvious to come up with loops like this and just magically get it working after like 45 seconds in total. Like, it'll be a struggle at first. But there are some patterns to follow. So one, it's pretty conventional, nonetheless, to use just I, and then J, and then K, and then L. And if you've got nested for loops, at some point nesting, you're probably writing bad code. It's not well designed. But 1 or 2 or maybe 3 nestings could be an OK thing. But you cannot use and reuse I again and again. Why? Because if you're counting I here, but then you're changing I here to do your columns left to right, you're going to get all of your math out of sync. So you need 2 separate variables. I and J are conventional, or row and column would work too. But if we go back to this idea of rows and columns, well, let me actually factor something out here, and this might help you instead. Suppose that you set out on this problem. You know you want to do something like 3 times, but you don't quite understand how to print those rows. Well, take a baby step, a bite out of the problem, and maybe do this. Create a function with no output, just a side effect, whose purpose in life is to print a row. And how many rows? Well, maybe n for some number of for some number of bricks, rather. How do you print a row of bricks? Well, let me just think about this in isolation. How do I print a single row of bricks? That's easy. For int I equals 0, I is less than n, if I'm generalizing, I++, and then, I++, and then inside of my curly braces, go ahead and just print out a single hash, and at the end, as you suggested, print out a single new line. In other words, abstract away the idea of printing a single row. And in fact, at this point in the story, especially if you're struggling to get started, you don't even need to start with main. Like, take a bite out of the problem that makes sense to you, that's smaller than the whole problem, printing a single row. Because then you can come in and iterate. Then you can go in and say, OK, now let's write my actual main function. So int main void, as always. And now what do I want to do? I want to print out a whole bunch of rows. How do I print out a whole bunch of rows? Oh my God, it's like the same idea. For int I equals 0, I is less than, let's call it 3 for now, but we can generalize that, I++. And what do I want to do on each iteration of this loop? My gosh, just print row with 3 bricks. And then we're sort of done, right? Again, out of sight, out of mind. This function can go away and never be seen before, because once print row exists, that's what it in fact does for me. Now, this isn't 100% correct. I still need my prototype, because if I've made my own function, I need to tell C in advance that it shall exist. So I need to copy and paste that one line of code. If I were really being pedantic, this is bad design. In general, when you have the same number in multiple places in a programmer would call this a magic number. Like, how is that working? Like, you're just an honor system that you're using the same number again and again. So a better solution here, even if you're not going to take user input, would be to do this. Int n equals 3, and then use n here, and then use n here. Or you could call it anything you want. But now you've specified 3 in one and only one place. And we can go one step further. It turns out in C and in other languages, you can protect yourself against yourself. If you know that a variable should never change its value, it should always stay 3 in this case, you can use what's called a constant, where you can specifically say, I don't want just n to be an int. I want it to be a const int. Const for short, for constant. And this means even if I try to change n in my code, the compiler will not let me. So I can protect myself from myself, or in the real world, you can use a variable that none of your colleagues can foolishly change on you without you realizing that it has happened. So a lot of programming, honestly, is just not trusting yourself the next morning when you've forgotten what code you wrote, let alone the next month, the next year when you're writing code in the real world. So constants just give us a feature to defend against ourselves. there's another feature that's useful too, especially when you wake up the next day and you're like, oh my God, like how does this code work? What does it do? Well, there's comments in code. And some of you might have used this in Scratch. You could add little yellow sticky notes in Scratch for comments. In code, you can do something like this. You can, if you want to put an English reminder to yourself, or if you speak some other human language, a comment in Spanish or any other human language, you can write it with a // at the start of the line, and then you can say something like print n rows. And then this tells you in a comment what those subsequent lines of code are doing. It's sort of a note to self. It has no functionality for the computer's sake. It just is a note to yourself. Or you can say something like this, like never change n, because you're making clear that it's indeed constant. But that too is a little pedantic since const says the same. But comments are notes to self to help you remember what something is doing or why you did it this way. Questions now on any of these Mario problems that we have solved? No? All right, so one final set of examples that push the limit of like what computers can actually do. Thus far, we've solved like every problem I proposed. That's because I've kind of been skirting some of the underlying challenges. So it turns out that we have not only functions that give us side effects, like visually on the screen, we again have functions that have return values. So let's focus on those and where things can go wrong, and let's use a bunch of other operators as well. Suffice it to say, computers got their start by being really good calculators, so computers support addition, subtraction, multiplication, division, remainder operators, represented by the percent sign here, which says take the remainder of something over something else, and there's even more operators than this. So let's go ahead and implement our own calculator of sorts that actually has some bugs along the way. Let me go back over to VS Code here. I'll close mario.c, open my terminal, and code up one final file called calculator.c. And in this calculator file, let's go ahead and do something super simple initially. Let's go ahead and include CS50.h. Let's include standard.io.h. Let's do int main void as always, all boilerplate thus far. And now let's do something more interesting. Int x equals getInt, and we'll prompt the user for an x value. Int y, prompt the user for a y value, as we've done previously for comparing numbers. And let's just do something super simple. Let's give myself another variable, int z equals x plus y, and then let's print out the sum. So printf, quote unquote, and I don't want %s here. If I want to print out a number, someone said it earlier, we want %s for string, but %i for integer, \n, and print out the value of z. So it's a little silly, this calculator. It just adds two numbers together, but it's going to demonstrate some points. So make calculator, enter. So far, so good. /calculator. Let's just say x is 1, y is 2, z is going to be 3. This code is correct, simple though it is. Is there an opportunity for marginally better design? Could we tighten this up, make it shorter? Fewer lines means lower probability of bugs, probably? Yeah. Yeah, we don't really need a separate variable z. I mean, it's fine if it's clearer to you, if it's clearer to your TF, if it's clearer to your colleagues, but honestly, this is so relatively simple, I think we just get rid of z and just say something like x plus y here, which is totally reasonable as well. But you don't want to take this to an extreme. Heck, if we don't need z, do we really need x and y? Well, we could do something like this. Let me actually delete these lines of code and claim, we can do this all in one very pretty one-liner. We could do, say, getInt x plus getInt y. And notice now, kind of like the join example last time, I'm calling getInt once, getInt twice. Both of them return a value, which is like going to be 1 and 2 respectively based on what I typed earlier. Then I'm doing 1 plus 2. That's going into printf as the second argument. Like, this is actually correct and will work. It's just stupid. Like, don't do this. Like, we've crossed some ill-defined line where this is just harder now to read. And so even though the variables aren't strictly necessary, I would argue, and I think most programmers would argue, this is just much more readable. Each line is doing a little bit less work. There's less chance for error. It just makes a little more sense. But reasonable people will disagree. So therefore, this is to say over time too, like you and your TF might disagree, you and your colleagues might disagree. And at that point is when the sort of religious debates kick in as to which way is the right way. All right, so that's one calculator. Let's do something else that maybe just like doubles a number here. So let me change this to just get one integer from the user. Let's just call it x, and let's just double it quite simply. So printf %i\n x times 2. We'll quite simply double it. The star operator is indeed multiplication in this case, so that's going to go ahead and double my number. So make calculator again, /calculator, enter, and let's go ahead and type in 1, and I get back 2. Let's run it again. Type in 2, I get back 4. Type it again. Let's type in 3, I get back 6, and so forth. All right, so that's not bad in this case here, but what if we actually want to write a proper program here?
What?
In fact, yeah, let's see. This is a sort of a meme that comes and goes. Let me see if you recognize this. I'm going to go ahead and say another variable, not x, let's be more specific, like int $=1. And then let me deliberately induce an infinite loop. Sometimes it is useful to induce an infinite loop so long as you eventually break out of it somehow, if you don't want the program to run forever. I'm going to ask the user a question, asking them for a char c using get char. And I'm going to ask them, quote unquote, here's %i period, double it, and give it to the next person, question mark. This is for ringing a bell, and then we can pass in to getchar the dollars value there. So actually, this looks bits wrap around from 1s to 0s, and it looks like all 32 of your bits are 0 because the 33rd bit was supposed to be the 1, but it's not there. They don't have enough memory. So this is a fundamental problem with computers whereby it is because of something called integer overflow. Forever? Yeah. Yeah, there's not enough bits to store bigger and bigger numbers. Recall with 32 bits, which happens to be how big most ints are, you can count as high as 4 billion if you start at 0, or roughly as high as 2 billion if you want to handle negative numbers as well, -2 billion to +2 billion. So eventually, once I get to like $2 billion or $1 billion, it goes negative, and then it just goes to 0 altogether. This is because of something called integer overflow, whereby if you only have a finite number of bits, and you keep incrementing them, eventually you can't just carry the 1 because there's no 33rd bit, so all of the other bits wrap around from 1s to 0s, and it looks like all 32 of your bits are 0 because the 33rd bit was supposed to be the 1, but it's not there. They don't have enough memory. So this is a fundamental problem with computers whereby if you count high enough, things will just start to break, at least if you're using C or C++ or certain other languages that don't anticipate this. And there's a very real implication of this. So here's a photograph of something we'll look at more in time to come, like of memory inside of your computer or phone or any electronic device. Suffice it to say, there's only a finite amount of memory, and if you're only using 32 bits then, or heck, even 3 bits, you will eventually overflow. We used 3 bits last week, so here's an example. In binary, if you're only using 3 bits per the white digits here, I've put in gray the 4th just to show you what carry we might want to have. Here's 0, 1, 2, 3, 4, 5, 6, 7, just like last week. And just like last week, someone said, how do we get to 8? We need another bit. But if that bit is grayed out because it doesn't exist, we've just overflowed this tiny integer and gotten back to 0, just like my money went to $0 instead. So how do we actually avoid that? You know, one way to do this is this. Let me hit Control-C to break out of the program, or I could just type no. Let me shrink my terminal window and clear it here. I could actually do this. It turns out that ints use 32 bits typically, but there's another data type that was on the slide before called long, which is a longer version of an int, which is 64 bits, which is crazy big. There's not that many dollars in the world, but it's still finite, even though I can't pronounce a number that big. But if we change all of our ints to longs, and we change our placeholder from %i to %li for long int, I can actually count higher and higher. So case in point, let me actually go back to my terminal, make calculate.
I don't think any of these work with the program I'm running. What? What are you doing, Olivia? What are you doing, Olivia? Why?
This is my show.
What?
Yes, I know that mine.
Oh my god.
This is mine night. Yes, it's mine. Yes, it's mine.
It's not gonna work because it's not the same.
Enter, make it larger again, /calculator, and I'm just going to keep saying yes, but faster this time. The sequence is exactly the same, but recall that once we got into the billions, it started to wrap to negative and then 0. This is a lot of money now. Like, longs are indeed longer, and I could do this probably all day long. Oh, interesting. No, okay. I shouldn't have said that. Can't do this all day long because eventually a long 2 will overflow. I just didn't think it was going to happen that fast. So a long 2 will overflow because we'll need a 65th bit, but the computer has not allocated it. So that too becomes an issue of overflow. To read an excerpt, like, these are very real world issues. And in fact, here's a photograph of a Boeing 787 years ago that actually had issues beyond the most recent issues with Boeing airplanes, whereby after 248 days, the Boeing 787 years ago can lose all of its electrical power due to the generator control unit simultaneously going into fail-safe mode, whatever that means. But if you dig into this, it turns out that there was a software counter in these airplanes years ago that would overflow after 248 days of continuous power. 248 days, why? Well, Boeing was using a 32-bit integer, and they were using it to count tenths of seconds. And it turns out if you do the math, after 248 days, you have used too many tenths such that you overflow the size of a 32-bit integer. The plane would essentially have this integer, this tiny, stupid little variable, overflow. But generally speaking, when your numbers suddenly go negative or 0, bad things happen. The plane could literally lose its power mid-flight or on the ground. And if you can believe it, anyone want to guess what Boeing's workaround was till they fixed the actual software?
We good?
Did a Lisa Frank New School Tiger. I got to finish it. We only got an hour in the first session. This session knocked it out. Yes. Oh, you can't have that.
Huh?
Oh no.
She said shh.
I'll pop.
We're talking about the neat adventure that we went on to where we went and dug up a lot of really cool stuff. And how that dump pile looks like it was back from the Great Depression. So that cream bottle helped time date the archaeologist dig that we did. And the way the mountain is cliffing off, there's like sediments of like years and then glass and broken metal and shit. And so whatever dump pile it was around the Great Depression era. And it looks like the old water tower, honestly. It's kind of cool. It's like we went with a metal detector out there, that shit would light the fuck up. Probably find something nice. Just a thought. What are you eating?
Juice.
Oh, fake juice? Okay. You're funny. You need diaper? You want to see the tattoo?
Yeah. Just documenting how difficult it is to study.
Story of my life. I'm still going to school after I get off work and then take care of the kids. And I'm 4 hours of sleep after tattooing all night as well.
Well,
Mommy.
I feel you.
well, if I'd stayed in the oil field, you wouldn't have to do any of that.
Then go back.
Then you wouldn't be complaining.
Yes, I would because
You'd
I
be
love
complaining
you.
about something else.
I miss you.
Oh,
I love you and I miss you.
Gotta complain about something.
Look at those big ass hoofs.
That's some big hoofs.
Yeah, you see how big my feet are? Those are about my feet size.
Man, your feet are tiny.
I got big ass feet. That's a big ass bonus. Stop saying ass. That's her.
That's cool.
When she wanted new school, Lisa Frank colors. I love my customers. They're so much fun. You can't have that. Come here. Come do diaper and I'll give you something. Come on. Alright. Give me loves. I haven't seen you all day. And then I'll let you have your moment.
No. Have my moment.
Come on. Let's go potty. Okay. You gotta go potty with me.
Where? What's that? Not even reboot the plane. Like, they were told every few days, certainly every 248 days, turn the power off, turn it back on, which stupidly is what all of us have been told for years with our Macs and PCs and phones. Why? Because sometimes, because of bugs in software, computers get into funky states, which is a colloquial way of saying, like, some programmer made a mistake and some counter overflowed or some condition wasn't handled and just weird, unexpected things happen. So rebooting just resets all of your variables back to their original values and sorts of gives you more time, more runway, in this case, no pun intended. There are others. In fact, one of the most famous ones from like the 1980s was the original Pac-Man game. Only had support for 255 levels. Why? They were using 8 bits. Recall that 8 bits gives you 256. But if you start counting at 0, you can only go to 255. So the crazy kids who were so good at Pac-Man that they got to level 256, the makers of Pac-Man did not anticipate that anyone was going to win that many levels, and just weird stuff happened on the screen. All of the fruits sort of started overwriting everything because they didn't have enough memory allocated to the level, nor did they have a condition that says if level equals 255, you win. Like, there was just nothing handling that corner case, so to speak. So these things abound even these days. Thankfully, in some languages, there are better solutions where you can use big integers, and you'll just use 64, maybe 128, maybe 256 bits, but you need to use a language or a library that allows you to grow and shrink the amount of memory being used, and many, if not most languages, do not do that for us. So there's a few final problems to see that we've been taking for granted thus far, and they also involve numbers and memory. So let's go back into our calculator. Let's throw away all of this meme code here, and instead, let's go ahead and do something simple again. Int x equals get int and prompt the user for a variable x. Int y equals get int, prompt the user for a variable y. And this time, instead of addition, instead of doubling, let's do division. So printf, quote unquote, %i \n, and then plug in x divided by y. So you use a single / for division. Let me go ahead and make calculator down here, / calculator, and let's go ahead and do 1 divided by 3, which should in fact be, well, it's not really 0, right? It's like 0.333. Let's try this again. How about / calculator? 3 divided by 2 should be 1.5. Nope, computer thinks it's 1. Well, what's happening here? Well, it turns out when you're using integers in a program, you are vulnerable to what's called truncation. An integer plus an integer gives you an integer. An integer divided by an integer, funny enough, gives you an integer. So even if the answer is supposed to be 0.333 or 1.5, everything in the world of integers throws away the decimal point onward, and you only get the integer part of the value. So it's not even rounding, it's truncating everything after the decimal. So this program is just not correct, but there are solutions potentially. For instance, if I go back into my code here, and I use a different format code we haven't used yet. We had S for string, I for int. There's also F for float. And a float was like a real number, something with a decimal point in it by definition. We just haven't used it yet. I could tell the computer to print this as a float. So let me do make calculator again. And now, it's specifying type double. There's an error here. The problem is that I can't just tell the computer to format this number as a float. I need to convert the number, x divided by y, to a float. And I can do this in a couple of ways. One, I could literally change all of this to floats and just avoid the problem altogether. Use float, use get float, use %f, and I'm done. But if I want to use ints for whatever reason, because I want the user to type in integers, but I want to show them real numbers with decimal points for correct math, I can do what's called casting a value. I can, in parentheses, which is a weird new use of parentheses, I can say, hey computer, please treat the following integer as a float instead, thereby avoiding truncation. Do not truncate for me. So if I now run make calculator again, /calculator, and type in, for instance, 1 for x, 3 for y, now I get an actual floating point value. I'm formatting it as such, and I'm telling the computer to actually arithmetically calculate it as such as well. But here too, I'm kind of cheating you of a reality. It turns out, let me clear this screen here, and it turns out that there are fancy ways in printf to tell it how many digits to show you, how many significant digits. And the syntax is very weird. I have to look it up constantly. But instead of just saying %f, you literally put some numbers in between there, and you say 0.5. And that will say, it's weird syntax, hey printf, format this to 5 digits instead. So let me go ahead and do make calculator again, /calculator. And let's do 1 divided by 3. And indeed, I get 5 significant digits there. But suppose I get a little crazy and I want 50 significant digits. Well, according to grade school, I should just see more like 3s, but watch this. Make calculator, /calculator, and it turns out that whoever taught you grade school math was kind of telling you some white lies, because if you really do it with a powerful Mac or PC or phone, 1/3 is actually 0.333333432674407. Who's right? Mr. and Mrs. So-and-so from grade school, or like the internet? What's going on here? What explains this? It all comes down somehow to weak zeros, zeros, and ones. Why is this floating point number imprecise, so to speak? What's the intuition? Yeah. Yeah, similar in spirit. Just as ints only use 32 bits, floats also use only 32 bits. If you want more, just as int has long, floats have something called double. So I could kind of avoid some of the problem by switching to double, but that's still going to be finite. And if you think about this intuitively, if you're using a finite number of bits, be it 32 or 64, you can only represent literally so many patterns, and thus so many floating point values, so many real numbers. But how many real numbers are there in the world? Like literally infinitely many is the challenge of real numbers. You can just keep adding numbers after the digit. So how could a computer, Mac, PC, or otherwise, possibly represent every floating point value super precisely if there's not enough patterns to represent every number in the world? Moreover, the way that computers use to represent numbers sometimes do not allow them to represent numbers so precisely. We can get more significant digits maybe, but not 100% perfection or precision. So floating point precision, too, is a fundamental problem with computers today. And unless, again, you're using a specialized language,
You talking about using the free code camp stuff? SWE. I don't even know what SWE is. Oh, software engineer. A single language. I don't know. I don't know what to do.
values. Then I'm going to manually say scores bracket 0 equals 72. Scores bracket 1 equals 73. Scores bracket 2. Well, it turns out that there is a way to address this, and to do better than this in code, we're going to introduce the first of our data structures this week in class, whereby we can introduce the notion of an array. An array is a sequence of values back to back to back in memory. An array is a sequence of values back to back to back, or contiguous in memory, all of which are the same data type. So int, 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 or char, 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 or something else along those lines. And the syntax for creating a single variable that contains not one, but any number of values is relatively simple in C. You simply specify what type do you want the values to be, int. What do you want the name of the variable to be, scores, plural, just for clarity. And how many integers do you want to be associated with this variable called scores? You use square brackets, which is something new now. But the square brackets indicate, hey, compiler, this is an array of 3 integers that will give me access to all 3 back to back to back in memory. So if I want to now initialize each of these values to numbers, the syntax is pretty similar to before, but I don't have to come up with new. come up with new variables.
You okay? No?